Hi, welcome to this video. In today's video, we would like to talk about a coding exercise. I think that it's better to learn the concepts when they're applied in exercises so we can feel the practicality of these coding exercises and the concepts that we're going to learn. Here, we would like to create a simple line plot for the function y equals x to the power of 2 for x values from -10 to 10. And we would like to have a customized line color of red. Okay. Now for plotting in Python, we need to import Matplotlib library. So in order to import Matplotlib library, we are going to simply call it here. And also for numerical operations, we need to have the NumPy library. Therefore, we are also importing the NumPy library here. Now we mentioned that we would like to have for x values from from -10 to 10. In order to generate the values for x, we are going to use the np line space function. This function requires 3 arguments, okay? So the starting point, the ending point, and the number of points that we would like to be evenly spaced, okay? Now this np line space function is going to have the start point to be -10, the stop point to be 10, or let's say the ending point, and then it is going to generate an array of evenly spaced numbers. So this is the third argument. So when we are having, for example, 100 points, it is smoothly having the curve when plotted, but if we are having lower number of, for example, points in our array, we are going to see that it's not very much smooth. We're going to test it now in a few minutes. So this np.linspace function, we used it to generate the x values for us, the starting point, the ending point, and the number of points in that array, and it is equal to our x. Now we need to have the y function here because y equals x to the power of 2. We need to have it. In order to compute y value for the function, for this function, we're going to have y equals x to the power of 2. So when we want to have the power in Python, when we want to have a number to the power of 2, for example, we are going to use star star. Okay. For example, 2 star star 2 means that 2 to the power of 2. Okay. It means that 2 multiplied by 2. So when we want to show the power in Python, we are going to use star star. So 2 to the power of 2 means 2 multiplied by 2, so their output will be 4. This was just an example, but in order to compute the value of y for this function, we first need to implement it. So it is the implementation of y equals x to the power of 2. Now we generated the x values, and we also computed the y values. Now it's the time for plotting our plot. Now, in order to plot our plot, we need to use the plt.plot function. This is a function that we can use for a custom color because we mentioned that here we would like to have a customized line color of red. So here, this function plt.plot is used to create a two-dimensional plot in Matplotlib library. Okay. Basically here, x is the horizontal values and y is the vertical values, and we are simply saying color equals red. So we would like to have the color red. Now the plot, we are creating the plot. We use the plt.plot function to customize the color and create the x and y axis. Now we need to label the axis and also the title. In order to label, we can have the plt.x label. So we are going to have the horizontal label, which is x-axis, and then plt.y label, we can call it y-axis, and the title of our figure, we want it to be this. This is the title parabola, and this is the title of our plot, and then we use the plt.show to show what has been done. So when I run this code, first of all, we see that the plot is in red. So let me put this a bit lower. So here we see that the plot is firstly red because we chose it to be red here. Okay. If I want a plot that is blue, I can have blue here, for example. When I run the code one more time, we see that the color has changed. So we can choose the color quite easily. Then we see that the title is parabola. This is exactly what we chose here. We can change to something else, for example, function. Now, if I run the code, we see function is the title of the figure here. Then we are having the x-axis and y-axis. We can change its title as well. For example, we can say it's time and it's not x-axis. For example, if the unit is time, we can write it down time here. We can change this one accordingly. So it's our choice. So I get back to the x-axis because it's easier to understand here. And this is the two-dimensional line chart that we see here that is shown in color blue. And you see that for values of x, we are having from -10 to 10 that we are having it here. As you see, among all this line, there are 100 points of x values to have a smooth shape. But if I change this 50 to this 100 to 50, let us compare. So you see that now the figure is a bit less smooth, but it's not very much identical. So if I put to number 10, for example, we should be able to see the difference. As you see it here, yeah, it's not that much smooth. You see some parts are sharper. You see it here? So it's not a good idea to have lower number of points. It's better to have sufficient number of points in order to keep the shape very smooth. So this was how actually we could create a line plot here and illustrate it simply here. And we could have, for example, y equals to x to the power of 3. So if I run the code, we see that the shape changes because now we are changing the y function. The y function was y equals x to the power of 2. Now it's x to the power of 3. So the shape is changing. But what if I do, for example, for x to the power of 4, for example? When I run the code, we see somehow the similar shape, but this part, the down part, is a bit more flat as compared to x to the power of 2. So you see the flat here, but when I have x to the power of 2, for example, we see that it's not that flat, it's more curvy in the downside. So let me also put the color red here and I run the code one more time. So this is how actually we can have a simple line plot for function y equals x to the power of 2 for values of x between -10 and 10, and we had a red color line. So in this video, first of all, we learned that if we want to use the Matplotlib library and do some numerical operations, it's good to import the Matplotlib library and NumPy. Then the second lesson of this video was that we learned about np.linspace, so we can generate values for x between the start point and end point and the number of points that we want to have in our array that are generated with evenly spaced. Also, we learned how to implement the function y equals x to the power of 2. So to the power of 2, we learned that if we want to do it in Python, we need to have star star, okay? Then we learned that in order to have our line plot in two-dimensional, we can have the plt.plot function and then simply contain the horizontal values and the vertical values and also choose the color. And this is how we can label the horizontal axis, vertical axis, and also the title of the plot. This is how we can label it. And finally, to display the plot, to display the plot, sorry, we can use plt.show function to have the figure being shown here. Thank you for watching. Hi, welcome back. In today's video, we're going to have a coding exercise to use different line styles. We would like to plot two lines on the same graph. So here we see that this is the first function, y equals 2 multiplied by x plus 1. And then here we are having y equals minus x plus 5. We would like to plot these two functions. And for the first one, we are willing to use a dashed line. And for the second one, we are willing to use a dotted line. Okay, so two different line styles. First of all, we import the necessary libraries. Then we are going to again use the np.linspace function. The starting point is -5, the ending point is 5, and we are going to have 50 points on this line for x. Then we need to, now that we generated the values for x, we need to generate values for y. So because we are having two y functions, we are going to define them separately. So we are going to have y1 and y2. So y1 is the first function, which is 2 multiplied by x plus 1. And y2 equals minus x plus 5. So this is exactly like the two functions that we are having here. Okay, now we generated the values for x and we defined our two functions. Now we need to plot these two functions with different line styles. In order to do that, we use the plt.plot function. And in parentheses, we have the horizontal line and the vertical line, so x and y1, because it's for the first function. Now, in order to have a dashed line, we write down line style equals, and then in quote, we are having two dashes, okay? With a comma, we separate it by a label. So we want to label it because we are drawing two plots in one figure. We need to label it. So this is the label saying that, okay, this line plot is for this function. Y equals 2 multiplied by x plus 1. Then we need to have the plot for the second function, but this time it's the dotted line. In order to do that, we again use the plt.plot function. We have x, and we are this time having y2. In order to change the line style, we are going to have line style, and in quote, we are having colon instead of dashed here, because there we were looking for dashed line. Here we are looking for a dotted line. So colon, and we separate it by a comma to have the label as well. So the label is y equals -5 plus minus x plus 5, sorry. Then we need to also label our figure. So the x-axis, the y-axis, and the title of the plot, we are labeling them here. We are also showing the legend to differentiate the lines. And then finally we show the plot. So when I run this code, we see here is our plot. So first of all, this is the legend. This is the legend for the labeled lines. So here we had the labels y equals 2x plus 1, y equals minus x plus 5, y equals 2x plus 1, y equals minus x plus 5. So these are the labels that we defined, but we are going to show them using the legend function. So if I simply comment this one and run the code one more time, we see that it disappears. So even if we label the lines, we need to include the legend function in order to have access, in order to, in order to have the legend being printed in the output here as you see it. Okay, so based on this legend, we see that the blue dashed line is having the y equals 2x plus 1. And then the dotted line is for y equals minus x plus 5. So this is how we can have the functions being shown in lines but different styles. And also we see that the generated values for x is from minus 5 to 5. So we see that from minus 5 to 5, we are having the x-axis here, and we are uniformly having, for example, 50 points there. So if I put it to 100, we see that because there is no curve, it's not that much tangible to see when it's 100 or 50. So we keep it with 50 because at some point some number is enough. So now here we see that the lines are plotted here. Then we talk about the labels. So we see that the x label is x-axis, that is shown here. The y-axis is again here and here in the figure, and also we are having the title of the figure here. So this was a good example in order to practice to have a dashed line and a dotted line rather than a simple line being shown in the output. Thank you for watching. Hi, welcome back. In today's video, we would like to talk about customizing markers, and then we are going to review different line styles. So here is the function that we would like to plot. Y equals sine of x with blue, so the color is blue, circular marker at each data point. So we import the libraries. We use the NumPy library to call the linspace function to generate values for x and assign it to x. So the starting point is 0, the ending point is 10, and we are going to have 20 points in this array. Then we use the NumPy library to compute the value for y. So we are having y equals sine of x, but in order to use the sine function, we need to call the np, which is called from the NumPy library. So this is how we can compute also the function of y that we have in the statement of the problem. Here is y equals sine of x, so we implement it here to compute the value for y. Now we need to have the plot function. So the plot function is from the matplot library because we are having it as plt. So plt meaning that we are calling it from the matplot library, and the plot is our function. So we are having the horizontal axis, which is x, vertical axis, which is y. Then because we were asked to have circular markers, we are going to have the marker equals O. So when we are having markers equal O, it is going to have circular marker shape. Then we are going to choose the line style. So the line style, when we are having one dash, it means that it's a solid line like a normal way. Then we discussed the color, which is blue. So we were asked to have the color blue. And finally, we are going to label the x-axis, the y-axis, and the title of the figure, and then we are going to display the figure. So when I run this code, we see that the figure looks like this. So here, this is the x-axis, this is the y-axis, and this is the title of the plot of the figure that we plotted here. So we see that they are exactly what we expected here. Then we are having a solid line because we chose it to be solid. The color is blue and the marker is O. You see at each data point, we are having an O marker. You see here? So when we were not having it, the line would have been something without these blue big dots. Okay? But now, because we were asked to have circular markers at each data point, we see that they are shown very nicely here. And also, we see that the x is being generated between 0 and 10, and there are 20 points. So from 0 and 10, and there are, if you count the number of these blue dots, you will see that there are 20 dots there. So if I want to increase this number to 50, let's see how it would change. So first of all, the shape is a bit more smooth, it's more curvy, and you see, of course, more dots there. So you see more dots there, and the curve is nicer. And we learned that if we want to change, we can change the color here. For example, if I'm willing to have a color red, we can have the color red here. Then let's talk about the line style. So one dash means that we are having a solid line. If I'm having two dashes there, we see that, let me change the color to blue and reduce the number of points. It's easier to distinguish the difference. So when I run the code, we see that now it's the dashed line, not a solid line. Okay. And also we learned that we can have dotted line using the colon. So when I run the code one more time, we see that we are having dotted line instead of dashed line. So this is another style. And finally, the last style that we could use is the dash dot line. So dash dot line, you see dash dot, dash dot, dash dot. So this is the dash dot line that we can see here. So it depends on what we are looking for, but if we are looking for a simple solid line, we can simply have it here. It is shown there. Also, there are different types of markers. So the marker that we are using, it's the circular marker, but we could have a V marker. So when I have V marker, you see that we don't have the circular, but it's different. We could have another marker, which is X, for example. So the X marker looks like this. We have, for example, star. When I run the code, we see the star here. When we are having another one, we can have P, for example. The P is this shape. We can have another marker like S. When I run the code, you see that this is the S. Okay, it's a square-like. And then when we are having, for example, this sign, we see that it's like it's moving to the right. And when we are having its opposite, it's like moving to the left. Okay, it's like moving to the left. So depending on what we are looking for and how we want to have our output, we can have different line styles and different marker as well. So now I get back to solid line with the circular marker with the color blue from x 0 to 10 with 20 points. So this is, in this lecture, we reviewed how we can generate the value of x. We learned how to compute the value of y when we are having sine of x. Then we discussed different markers that are possible to be used. We reviewed actually different line styles here, and then we plotted our figure. Thank you for watching. Hi, welcome back. in today's video, we're going to have another coding exercise. We're going to combine colors, line styles, and markers. So we are going to plot this function y equals to, in parentheses, we are having negative 0.3x, and we are closing the parentheses, and then we are having the cosine of 2x. Okay, so this is the function that we would like to implement, and we would like to have the following customization. So line color, we want it to be green. We would like to have a dash dot line, and then we would like to have marker squares or S. So now we import the libraries that are necessary. We start generating the values for x from 0 to 10. So from 0 to 10, we are having 50 points. Then we are going to compute the y values. So this is how we can implement this function. So y equals, in parentheses, we are having negative 0.3 multiplied by x, and the whole parenthesis is multiplied by cosine of 2x. Okay, so this is how we're going to have it here and being implemented here. And in order to have the cosine, we need to use the NumPy library. Then after having that, it's time to plot with the customization, to plotting the figure with customization. So we use the plot function. We have the horizontal line to be x. We have the vertical line to be y. We have the color to be green because we were asked to have that. Then we are going to have the line style to be dash dot, the marker to be S, and finally the label that we are going to have here. So the label that we are going to have is exactly the function that we were having above. So there we are going to have the label for the x-axis, y-axis, and also for the title. And because we were having a label, we are going to also show the legend because we want to see the legend also. And this is how we display the plot. So when I run the code, first of all, we see the x-axis, the y-axis. These are the labels that we gave. These are the labels, and this is the title. So we see it here. Then we see that we are having dash dot. So dash dot dash dot. So we see here. So it's a dash dot style. The color is green. So X is on the horizontal line and Y is on the vertical line, as you see. So the first one is X, therefore it's on horizontal line. Then we see the label, and the label is shown here. Okay, so the label is shown here because we are having the legend function. So if we are labeling and not using the legend function, nothing will be shown here. So the label is also shown because we are using the legend function. And also we see that the marker is a square, so we see that it's like a square, and we could have different styles. We could have, for example, X, but we were asked to have square. So we see that when we are having X, it's more clear to have dash dot line here. So we were asked to have it to be square. And also the value for X starts from 0 until 10. 0 until 10, and we see that there are 50 points if you count the number of these squares, these data point. You see that there are 50 there. If I reduce it to 20, for example, we see that the shape is not that much smooth and that it's not that much curvy anymore. And if we have, for example, 100 points, we see that it's very smooth, but we cannot see the line clearly. So we need to find the balance there to see which photo and which figure we like it most. I think with 50, it's okay. So here we learned, first of all, how to implement a cosine using the NumPy library. We reviewed the generation of X, we implemented the value of Y, we had a customization of dash dot, the green color marker S, and also we had the label, with the legend function to be shown here, and we were labeling the title and also the horizontal axis and the vertical axis. Thank you for watching. Hi, welcome back. In today's video, we are going to have multiple lines with different customization. So we are going to plot the following functions. These three functions. We want to have y equals to x to the power of 3. So let me put the power, okay, to the power of 3. And we would like to have a solid line, a red line with square markers. Then we would like to have another line, which is this function, y equals to, in parentheses, we have minus 2 multiplied by x to the power of 2. And we close the parentheses plus 5. We would like to have a purple dashed line with triangle marker for this one. And finally, we are having a function y equals 3x minus 4, which is an orange dotted line with cross markers. In order to plot these three customized lines, we are going to import our libraries. Then we are going to have the generation for x values from minus 3 to 3. We are going to have 30 points, okay? And we are going to use the linspace function from the NumPy library and assign it to x. Then it's the time for us to define our functions. So because we are having three functions, we are going to label them y1, y2, and y3. We have x to the power of 3, which is this one. Then we are having y2, which is negative 2 multiplied by x to the power of 2 plus 5. And finally, y3 equals 3x minus 4. Okay, so these are the implementation of our three functions. After that, we need to plot these functions. So we plot the first function x and y1, and we said that we want a solid line, so we are having only one dash. The marker should be square, so the marker is S, and the color should be red, so the color is red, and we are going to label the function as well. Then we are having the second plot, x and y2. The line style is 2 dashes because we wanted to have dashed line, and because we wanted to have a purple one, we are having the purple color, and triangle marker is there. So the triangle marker is like this, and then we are having the label. Finally, for the third function, we are having x, y3, because x is the horizontal line and y3 is the vertical line. So we are having the dotted line. So dotted line, we use colon. The marker, because we want cross markers, we are looking for x here. It should be orange, so we are having the color orange, and then we label it as the function is. Okay. After that, we are going to label our figure. So x-axis, y-axis, and multiple custom styled lines. So this is the title. Because we are having the labels here, we need to use the legend function in order to have it here. Okay, so if I comment this legend function as we see here, this will disappear. But this is now it's hard to see what is what. Okay, so this legend function is very helpful to understand the labeling. So you see that the square marker with the red line is for this function, for example. So I know, okay, red is my first function, for example. And after that, we simply use the show function to plot the figure. Here is my figure. This is the x-axis, y-axis, the title. This is the legend. And these are our figures. And as we see, the first one is red. X starts from -3 to 3. And it has 30 points on each of these lines. There are 30 points. And we see that it's
the representation of x to the power of 3. Then we are having the second function here, which is shown by triangle purple. We see it is shown here. And then finally, we are having the third function with the cross marker. So we see it here also. Thank you for watching. Hi, welcome to this video. In today's video, we're going to talk about customizing line width. Now we would like to plot a function, which is this one, y equals x to the power of 2, and x ranges from -10 to 10, and we would like to set the line width to 3. So we import the necessary libraries. Then we're generating here the x using the linspace function between -10 and 10, and we are going to have 100 points, and this is my function y equals x to the power of 2. Now that we want to plot this function, for the horizontal line we are having x, for the vertical line we are having y, for the color we are having blue, and this is something that we choose ourselves. We could have it like green, red, purple, whatever. But the important thing here is the following. So we want to have the line width to be 3. So now I am having line width to be 1. As you see, this is my line now, but I want it to be 3. So when I change it to 3, you see that the line is thicker now. So this is how actually we can have the line width. And then, as always, we are having the labeling for the horizontal and vertical axis and also the title. And here we are showing the plot. So in this video, we learned that if we want to have a customization for the line width, we can have it using the line width when we are plotting the function, and simply we are going to choose the number that we are looking for. For example, if we want to have the width of 5, we see that it's much thicker now as we see it here. So it depends on what we're looking for. We can customize it as we want, and this is how we can use the line width customization in order to plot our figure. Thank you for watching.
Hello, welcome back. In today's video, we would like to customize our marker size and edge colors. Here is the function that we want to plot. So y equals sine of x. For each x from 0 to 10 with these customizable features. We would like to have circular markers with the size of 8, edge color to be black with the width of 1.5. So far we learned how to use the Python to import the Matplotlib and NumPy libraries. And here is how we are going to generate the values for the variable x using the linspace from the starting point 0 to the ending point 10, and we would like to have 20 points in this array. And here is the implementation of our function y equals the sine of x, and we are using the NumPy library to write it down. Now it's the time to plot our figure and our function, let's say. We use the plot function. For the horizontal line, we are having x. For the vertical line, we are having y. The marker, as it was discussed, we would like to have a circular marker and we need to use O. So we are having the marker O. We said that the size of the marker was supposed to be 8, so we are having this keyword marker size and we put it to be 8. Then we are having marker edge color to be black. Then we are having marker edge width to be 1.5. So this is the edge width and this is the color of the edge that we chose. We would like to have solid lines, so we use 1 dash and we want it to be green. Okay, so this is the features that we want to have for our figure to plot our function. Then we are having the labeling of the horizontal axis, vertical axis, and sine wave with custom marker. This is the title of the figure, and this is the function that helps us to plot the figure. So we see here, this is the figure. So we are having the x-axis, y-axis, the title of the figure as we are having it here. Then we see that x starts from 0 to 10. So from 0, you see from 0 to 10. And there are 20 points here on the figure, as you see, because we chose to have only 20 points. So if I increase this to 50, for example, and I run the code one more time, it will generate a new figure for us in which there are, instead of having 20 figures, we are going to have 50 figures. Sorry, instead of having 20 these dots here on the figure, we are going to have 50 data points. Okay, so these are now 50 data points as you see here, but I think 20 was okay. So let me go back to 20 and I run the code one more time. So I think it's not very much smooth, but it's okay for our example because we are going to emphasize on other things in this coding exercise. So the first thing is that we are having the marker to be O. So you see that the data points are shown as O. If I wanted to have, for example, cross, we could have X. So if I run, you see that it's now X, but we wanted it to be O. So O is this is the circular marker. Then we are having the size of the marker, which is 8. So you see that the marker, the data points are quite big. So if I put number 2 here, for example, we see that it's smaller. If we have number 4, it's a little bit bigger, and we can actually customize the size of the marker here. But we were asked to have a marker size of 8, so I'm going to leave it to be 8, but it's optional. It depends on you. So if you want to make it larger or smaller, you need to play with the marker size here. After that, you see that the marker edge color is black. So you see these parts are black. The edge part of each data point is black. You see there? So I can put it to be, for example, any color. We can put it to be red, for example. If I put it red, it's more, it's easier to see it, to trace it. So you see that it's red, or we can have even green. So if it's green, it's even not identical, the edge and the point. So because they are having the same color. But we were told to have the edge color of black. So I will keep it to be black, but just keep that in mind. If you were working with the edge color, you can use the marker edge color keyword to assign any color that you think that it is good for your figure. Then we are going to talk about the edge width. So the edge width here, you see it's 1.5. If I make it larger, so if I put, for example, 4, here you see that it's a thicker. You see the edge width, it's thicker now. So if I put 3, for example, you see it's not that thick anymore. If I put 1, I can see, okay, now it's very nice. But we were asked to have 1.5 for the marker edge width, so I leave it as it is now. But just keep that in mind if you want to modify this and you want to customize it, you need to use marker edge width here. Then we are having the line style. We wanted a solid line. We are having a solid line. And we learned that if we want to have, for example, a dashed line, we're going to have 2 dashes. So it will be dash line, or we could have, for example, dotted line. Here it's my dotted line, or we could have a dash dot uh, line. So this is the dash dot line, but I'm going to leave it to be solid because it's nice, I think. It's nice. And finally, we are going to have the color. So the color of the figure is green. So if I want, I can have it to be red, for example. It depends on us. Whatever we want, we can go for it. So I will leave it to be green also. So I run the code one more time. Okay. So in this example, we learned how to discuss the marker size, edge color, and edge width, and we use all of them here in our example. For example, here we were discussing the marker, then the marker size, then the marker edge color, which was black, marker edge width, and line style. We learned it already, and the color as well. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to work with hex and RGB colors. RGB colors are red, green, and blue. So a color model where colors are represented using three values, red, green, and blue, each ranging from 0 to 1 in a floating point, or 0 to 255 for integers. And this hex or HEX is hexadecimal, and it's a 6-digit hexadecimal representation of RGB, where each pair of digits represents the intensity of red, green, and blue. And usually it looks like this. Okay. So now we would like to work with these two concepts in Python using the Matplotlib library. So if you're having a code for your color, so there is a specific color that you want to use for your figures, here is the solution for you. We're going to import the libraries. We're going to generate the X using the len space between -3 and 3, and we would like to have 30 points. And this is the function we want to plot. Y equals x to the power of 3. And this is our hex color. So it is orange red. And this is the RGB color that we want to have, blue green. It's blue green. 0.2, 0.6, and 0.8. So whenever we are dealing with the hex color, we are going to have something similar to this. So we are going to have a 6-digit representation. And whenever we are working with RGB colors, we are going to have 3 numbers. Okay. Now this was my X. So between -3 and 3, and there are 30 points there. Then we are having two functions. One function x to the power of 3 and one function minus x to the power of 3. We are going to have these two functions. Okay, so this is the original function that the question was asking, and we're going to have its representation in negative form just to test these two colors. Okay. Now we would like to plot our functions. In order to do that, because we are having two functions, y1 and y2, we are going to use plot function 2 times, one for x and y1 and one for x and y2. So x and y1 are the horizontal and vertical axis respectively. We are going to use the solid line, and this is the color that we are having here. So this is exactly the hex color that we were having in the question, which is orange red. And we are going to have a label hex color, and this is the code for the color that we're going to write it in our label as well. Then we are having the plot function here for the x and y2. We are going to have dashed line here to differentiate a bit from the first one, although the colors are also different. Then we are having the colors. This time it's a RGB format. So the previous one was a decimal here. So you see hexadecimal representation of the color, but here we are having this format: red, green, and blue. So, and after that, we are labeling our figure saying that RGB color, and this is the RGB color. And finally, we are going to label the x-axis, y-axis, the title of the figure, and because we are having labels here and we want to show them in the figure, we are using a legend function, and we are going to show the plot. So this is the plot that we were looking for. This is the legend function work. So we were having some labels for our functions to be plotted. Now using the legend, we can see it here. So here for the hex color, we are having this code and we see that this is a solid orange line. So this one is the first function that we worked with. And this one is the RGB color with this code, and it's with the dashed line, and you see it's like a bluish color as we see here. So again, like always, we are having the title, we are having the y-axis label, x-axis label. X is between -3 and 3. And also these were the two figures that we plotted here. So in this course, we learned that if we want to use RGB or hexadecimal representation of colors, we can have them in Python. And this is the way that we can use the specific code if we are looking for a specific color to use in our figure. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about adjusting transparency or alpha channel, let's say. Here is the function that we want to plot. Y equals cosine of 2x. And we want to have semi-transparent. So 50% of the alpha degree, we want to have it, okay? In order to do that, we first generate some values for x. Between 0 and 10, we would like to have 50 points. Then we are implementing our function y equals cosine of 2 multiplied by x. So this is, so far, it's what we have been used to. Now we are using the plot function for x for the horizontal line and y for the vertical axis. Then we have the color to be purple, the line style to be solid here. We learned about the line width, so we want it to be 2. Then we are having the alpha, which is the transparency adjustment of the line. We wanted to leave it to be 0.5 for the moment, and the label that we are having it here, that alpha is 0.5. Then we are having the x-axis, y-axis, and then the title. And because we are having a label here, we are using the legend function. And finally, we are showing the function, displaying the plot. So here is my plot. It's x between 0 and 10. It's cosine of x. Here, it's cosine of 2x, sorry. And the color is purple, it's solid line, and the width is 2. We see that it's a bit thick. Then the alpha is 0.5. You see that the transparency level. So if I change it, for example, to 0.1 and I run the code, we see that the transparency degree has reduced. And if I want, I can have more transparency. For example, I can have 0.9 and I run the code. Let me also adjust the label. So 0.9, when I run the code, we see that, okay, now it's stronger. The color is stronger as compared to the previous version. So here is how we can change the degree of alpha. We can go to up to 1, and we could have the, for example, 0.5 to be in the middle range. So 50% is what we were asked to do. So because of 50%, we put 0.5. This is how we can have the transparency adjustment for our figure. Thank you for watching. Hello, welcome back. In today's video, we are going to work about creating a basic scatter plot. First of all, we are going to import the necessary libraries. So this library, Matplotlib library, is for plotting, and NumPy is for numerical computation. Because we want to just create a basic scatter plot and we don't have any numbers at hand right now in this coding exercise, we are going to generate randomly some numbers for us, and we're going to learn how to generate numbers actually. So here, in order to generate numbers, we are going to set the random seed to 50, ensuring reproducibility of random numbers generated by NumPy. So random.seed, and then we're going to use an arbitrary number there. It can be 40, it can be 50, it can be 60. It's your choice. It has no impact now on our example, therefore I just choose it to be 42. But this function is very important to be called, because now that I have this function, if I run the code several times, I'm going to get the same result. So it's going to seed the it is going to set the random seed for me. So every time that I'm going to rerun the program, it is going to have the same output. We are going to test it. After that, we are going to generate values for x and y. So we are going to have x and y coordinates. And we're going to again use the rand instead of random seed. We're going to have random rand number 50. So it is going to generate 50 numbers between 0 and 1. Then we are going to use random.rand function to have 50 numbers again for y. And basically we are going to simply call the scatter function and put the x to be the horizontal axis and y to be the vertical axis. When I run this code using this function, we are going to display the output. So here is my output. You see everything is between 0 and 1 and 0 and 1 here. So all the data that we generated is between 0 and 1. So 50 numbers for x coordinates and 50 numbers for y coordinates, and we are here having the output of x and y. Now, when I run the code one more time, you see that the figure does not change. And for example, this dot there, it stays there, you see. However, if I remove this function, a random seed that sets the random seed for me, now that I have this result, if I run the code one more time, we see that the figure is totally new. When I run the code, it's totally new. Another new figure, another new figure. So this function helps me to have one-time generation and then use it for the rest of the code execution. Okay, so now if I run the code one more time, we see that no, okay, everything is staying the same. This function helps to set the random seed to a specific number, and then whenever we rerun the code, we are going to see the same result. However, if we don't want to see the same result, we can comment this part, and as I showed you, you can have different results. Basically, in this video, we learned that we can generate random numbers between 0 and 1 using the random.rand function from the NumPy library. And also, we learned that it's important if we want to have one result for each run, we need to have the random seed function in order to set the random seed to a specific number, an arbitrary number. We can choose it, it's not important. So ensuring reproducibility of random numbers generated by NumPy. And also we learned that when we want to plot a scatter plot, we need to call the scatter keyword here. A scatter keyword needs to be there. So a scatter function will be called, and then we display the plot using the show function. Thank you for watching. Hi, welcome back. In today's video, we are going to discuss another scatter plot. Here, again, we are importing the necessary libraries, and we are going to simply have x and y being generated randomly without having the random seed. So every time that I run, we are going to have a new figure. So you see, when I run, I have a new figure each time because we didn't set the seed here in the beginning. If we wanted to have that, we needed to have random dot seed and a number, for example 50. If I uncomment this part, we are going to have the same figure whenever I run the code. But because I don't have this one and I'm directly using the random generation numbers for x and y, we see that every time that I run the code, we are having a new figure. Then the second thing that we're going to learn in this video
is the fact that we can work with the size of our figure. So this is the size of the figure. So we can have the figure function, okay? And in parentheses, we write down the fig size equals, and then the length and width of the figure is entered there. For example, this is the length and width of my figure. Now it's 10 by 5. If I write down 2 by 1, for example, you see that it will become very small. You see? But if I have 20 by 10, for example, it will be very large. You see? So this way you can adjust the size that you want for your figure using the figure function, and the fig size keyword equals the length and the width. So here is how I'm defining the figure size. Then I'm generating the random numbers for x and y. And now I would like to plot the scatter plot. We use the scatter keyword. We are having x for the horizontal axis, y for the vertical axis. Then we can modify the marker and the size of the marker type, let's say, the size of the marker, and the color. Here, the marker is now O, which is a circular, as we discussed before. The size is 100, and the color is B, which is blue. Here are different markers that we can use. These are just examples and different colors. So the marker is O now. We can have a marker S. We discussed this before in the line plot. You see S, it's here. We can have D, for example. You see it's here. And we can have a triangle like this. So it depends on whatever we want. We can have V, star, and X as well. So I'm going to use V, for example, here. So when I have V, we see that it looks like this. And then we can have the marker size. So it's 100. We can have like 80, for example, if we want. When I run the code, you see they're a bit smaller. So I put, for example, 20. I run the code, you see that it's much smaller now. And here is the color that we can have. For example, B is blue. And if I put, for example, G, it will change the color to green. So you see that now it's green. You can also write down green here. You can also write down the full name of the color, for example, red. So it's red. Either you can use the keywords or you can have the full color being written there. So in this lecture, first of all, we learned about the size of the figure so we can modify the size. And then we learned about different marker types when we are plotting, the scatter plot. We learned about the marker size, and also we learned about the color modification. Thank you for watching. Hi, welcome back. In today's video, we're going to discuss random sizes for our figure. Here we are importing the necessary libraries, Matplotlib library and NumPy. And then here, I will discuss this line later. Here we are generating random numbers for x and random numbers for y. Then we are having the scatter plot being plotted. We are having the horizontal line for the x and vertical line for the y. And we are having the S for the size. We could write down, for example, 10 for the size for the moment. The color to be blue, and the transparency adjustment we put 0.5. And we're going to plot our scatter plot. So when I run the code, we see that here is our figure. So for the x and y, we generated 50 coordinates randomly between 0 and 1. For example, this is our first point with its corresponding x value for x coordinates and its corresponding y value for the y coordinates here, okay? So we are having 50 points now. If I run the code one more time, we see that it generates new points on our figure. So we see that using the random number generation, when we are not having the seed function, whenever we run the code, we are going to see a new generation. So I run here, we see a new generation again. And this is the transparency adjustment. It can be up to maximum 1. So you see that it's more strong, the color. And if we are having, for example, 0.1, we see that it is adjusted quickly and now it's not that strong. So I put it to be 0.5. But one thing that I would like to discuss in this video is the following. We can have also random sizes. S is for our size. For example, we can put 10, we can put 50. When I put 50, you see that they are bigger. We can have, for example, 500, and you see that they are much bigger. And at some point, there are overlaps here as well. So how do we generate it randomly? If we want to generate it randomly, we create a new variable here called sizes. Then using the random and randint function, we are going to generate random sizes for our figure. This is the starting point. This is the ending point, and these are the numbers of the sizes that we want it to be generated. So when we are using the random dot randint, we are going to have random integer numbers to be generated, and there are 3 arguments. So the last one is the size equals 50. So this means that we want 50 sizes. Okay, because we were having 50 points here, we need 50 sizes for our points as well. So this is why we are putting the 50 there. Then we need to have the starting point, and ending point. We want to have sizes to be minimum 50 and maximum 500. Okay, so it is going to generate a number between 50 and 500, and it is going to do it 50 times. So now that we are having this variable sizes, I copy this name, and instead of 50, I paste sizes. So when I run the code at this time, we see that the sizes are different. Why? Because we generated 50 sizes between 50 and 500, the starting point and the ending point. And because these numbers are random, they're not equal to each other. So one point is going to get this size, one is going to get this size, one this one, one this one, one this one, for example. So they vary in this range. Okay. However, if I fix it to a number, for example, if I fix it to 50, we are going to have the sizes to be the same. But if we are putting the sizes there, the sizes is having 50. It's like an array with the size 50, and it has these 50 points are generated between 50 and 500. Okay, so let me change this 50. So 100 and 500. So you see that these are the points that are generated in this size, and these are 50 points because we are having 50 x and y, and these are the coordinates of our points that we want to show. So in this video we learned that we can have random sizes for our points to be shown here. Thank you for watching. Hi, welcome back. In today's video, we would like to have color markers based on values. So instead of having a single color, we would like to have a color map based on another variable. So we are going to generate randomly values for color. Now here is the function rand that we are going to generate 50 numbers between 0 and 1 and assign it to colors array. Okay, so far we're just generating 50 numbers, randomly between 0 and 1 and assigning it to colors array. Then we are having here 50 x coordinates and 50 y coordinates being generated randomly between 0 and 1 again, and they are being assigned to x and y. Now we would like to plot our scatter plot. So here we use the scatter function. We are having x and y, horizontal and vertical axis. Then it's the size. We are having, for example, 100. Then it's the color. So now we generated 15 numbers between 0 and 1, and not colors, but how we are assigning it to the colors that we want to show for our figure. The point is here, we are having a color map. So a color map is going to use these 50 generated values to act as a color indices for color map. Okay? And when we are using the scatter plot, let's say a scatter function, Matplotlib library maps these values into this color map, okay, and assign a unique color to each point. Let me review it one more time. So here we generated 50 numbers between 0 and 1 and assigned them to colors. These 50 numbers that are generated here are acting as color indices in our color map. And when we are using the scatter function, Matplotlib library is going to use these values, okay, into our Virdis color map, assigning a unique color to each point. We're going to see the figure and we see how it's easy to have a color map. Then we are having the alpha, the transparency adjustment. And finally, we are having a color bar here to show the scale of the color. And we are plotting our figure. So when I run the code, we see this is our figure. First of all, x and y are between 0 and 1. We see the color bar here that has the labor color scale. And using the color bar function, we are having this color bar. Okay, so you see it starts from 0 and it is until 1. So exactly the 15 numbers that we generated for the color array, they were between 0 and 1. Okay, and we use the color map Virdis to assign each point a random color. For example, one color had the number equal to 0.5. So 0.5 on our color scale is somewhere here, and the color is this. Okay, they may had a number like here 0.1, so this is why the color is like more similar to purple, if I'm not mistaken with the color name, because here we see that there are different colors in this color bar. Okay, so this is how we can have color map to have different colors being shown on our color bar. So we learned that we are generating 15 numbers, and we are going to use those 15 numbers that are generated between 0 and 1 in our color map. And the name of our color map in this example is Viridis. Okay, so this is the name of our color map. But there are different color maps that we can use. Here is another one. Plasma, for example. We can have plasma. If I run the code one more time, we see that the color bar changes because we are changing the color map. We can have the inferno, for example, here. So if I run the code one more time, we see that it changes. We are having magma, for example. So if I run the code, we see that it's different. And finally, if we are having CVDIS and I run the code, we see that it's totally a different color scale. So this is basically how we can have random numbers For colors, we generate 15 numbers between 0 and 1. And we are going to use those 15 numbers in our color map, and we can use different color maps, for example, CVDX, and each color is going to assign a unique color. Okay, each point is going to be assigned a unique color based on the number from 0 and 1, because our color scale is from 0 to 1. So for example, one color is having number 1 and it is getting this yellowish part or creamy part, let's say, and then 1 is getting number 0.1 and it's stronger color and it's more like a blue, let's say. So this is how basically we can have random colors and a color bar in a scatter plot. Thank you for watching. Hi, welcome back. Now we would like to combine multiple customization. Now let's put everything together to have a coding exercise in a single plot to do a lot of customization. Here is our libraries that we would like to import. We are generating x and y coordinates, randomly 50 numbers between 0 and 1. Here also we are having the generation of colors, 50 numbers, again between 0 and 1, because we are going to use these 50 numbers that are between 0 and 1 for our color map, and each point is getting one unique value of this 50 generated numbers. And we are going to use a color map, so each point is assigned a unique color. Also, we would like to have different sizes. So we are generating random integers between 100 and 300, and there are 50 50 numbers in this array. Okay, so we are going to have 50 integers being generated between 100 and 300, and it is assigned to sizes. Okay, so this is how we can have different sizes. Then we would like to plot our scatter plot. We are having x and y for the x-axis and y-axis. We're going to have sizes, so s equals sizes, so we're going to have varying sizes, different sizes that are generated randomly between 100 and 300, and because we are having 50 points, we generated 50 sizes. Then we are having the colors being equal to the 50 numbers that are generated for colors between 0 and 1, and then we are using those values in our color map, and we are having the cool warm color map to assign each point a unique color. Then we are having the alpha, which is the transparency adjustment, so we would like to have 0.6. We have the edge color equal to black and line width to be 1.2. Then we are having the title of our scatter plot. We are saying customize scatter plot, and in order to modify the size, we can have font size equal 14. Then we are having the label for x-axis and y-axis. Again, we are having the font size customized to 12. And then finally, we are having our color bar being here used. So we use the color bar function and label it to be color scale. And then we show the figure. So when I run this code, we are having a figure like this. First of all, the x-axis label, the y-axis label, and we see that all the points are between 0 and 1. So this is our figure. This is the title, customize a scatter plot, and you see that the font size here is larger than the y-axis label and x-axis label. So this is what we do here, okay? Then we see that the sizes are different and the colors are different. So for the sizes, because we had different sizes here, 50 sizes were generated between 100 and 300 and assigned to the sizes array and assigned here. So for each point that is having x and y coordinates, we are having one unique size. Then for the colors also, we generated 50 colors, 15 numbers, let's say, between 0 and 1, and assigned to the colors array. And we use those values to use the color map cool warm. And this is why each point is getting a unique color. You see that the color scale is between 0 and 1. The more we are close to the 1, we see that the color is more getting close to somehow a reddish color. And we are having the alpha equals 0.6. We could have, for example, 0.1 to have less transparency. You see, as we increase this number, we are going to have more transparency. So when I run, we see. And finally, we are having the edge color and line width. So the edge color is black. You see, it is a black in the outer layer of our dots. If I put, for example, green, it's more transparent. You see that what I am talking about. Okay, so now it's green. It's green. So you see that the edge is different now. Then we are having the line width. It's set to 1.2. If I set to 3, for example, you see that the width of the edge is thicker, so it is something that we can customize as well, and we see the green color more clearly now. So I will go back to 1.2 and I will go back to black for the moment, but you can customize it based on your need and based on what you're looking for. So in this video, we learned different things. First of all, we reviewed how to have different colors and varying sizes. Then we learned about a new color map called Coolworm. We discussed about the edge color here and the width of the edge here also. We learned how to have font sizes customization for our labels, and we saw that here the title's font size is larger, for example, than the y-axis label. Thank you for watching.
Hello and welcome back. In today's video, we are going to discuss annotations. Here, we are importing the necessary libraries. As always, we are generating numbers for x and y. So we are generating randomly 20 numbers between 0 and 1 for x coordinates and do the same for the y coordinates. Then we are having the figure size of 8 by 5. Okay. So it's 8 inches by 5 inches. Then we are plotting our scatter plot. Here, x and y are horizontal and vertical axes respectively. The size is 100. The color is red, and the alpha, which is the transparency adjustment level, is 0.6. So far we have no problem and everything goes well. Here we would like to run the code and show you how the code works. So you see we are having between 0 and 1 and 0 and 1 here also. We are having 20 points and they are red with the size 100. And what else? Okay, the transparency level is 0.6. You see that there are two labels here in the figure. So these 2 points are labeled. How do we do that? Here, in order to have labels, we are defining a for loop for for each I in the range between 0 and the length of the variable x, which is 20, to iterate through the points, iterate over the points, and label every 10th point. So because we are having 20 points and we want to label every 10th point, we are only having two labels in the output. Okay, so if I write down label every 2 points, for example, when I put 2, you see that we are having 10 points being labeled here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every 2 points, every second point is labeled now here. So it depends on us. So we are going to choose, for example, every 10th points to be labeled. So when I run the code, we see here. So in our for loop, we start from 0 and we go until the length of the x, which is 20. And every 10th point, it is labeled. Then we are going to use, in this for loop, we are going to use annotate function. And this annotate function helps us to add labels to points. So first of all, we are going to say display the coordinates with 2 decimal places. Okay, so they display the coordinate of x, display the coordinate of y with 2 decimals. 2f dot 2f means 2 decimals. Okay, so you see that we're displaying x and y with 2 decimals only. So this is how the first part works, and the first part is separated by a comma, and then here the coordinates of the points to annotate is shown, for example, x and y. Okay, then we are specifying the coordinate system for the text position, and we are choosing offset points. And here we are going to mention that, okay, offset the text 10 pixel to the right and 10 pixel down for better visibility. So you see that it's a bit to the right and a bit to the down. Okay, so if I increase this number, for example, you see here 20 and minus 20, you see that the distance is larger, you see, as compared to 10. So let me go to 5 now. Just look at this figure. You see, they are very close now. They are like having overlaps. So this is something that we can modify. We can have 10 to the right, 10 pixels to the right, and 10 pixels down for better visibility. And then we are choosing the horizontally align to the text, horizontally align the text, sorry, at the center. We could write down left, for example, or right if we want. It's completely optional. For example, you see it is aligned to the right. We could have alignment to the left as well. So we are having the alignment to the left. And that's it, actually. This is the annotate function that is going to help us to add labels to points. Let me review it one more time. We are going to have for each I, because we are having multiple points. So because we want to label multiple points, we need to have a for loop. And we are going to have for each I in the range between 0 and the length of the variable x, which is 20. We are going to label every 10th point. Then in this for loop, we are going to use the annotate function. And this function will help us to label the points. So here we are having the displayment of the coordinates with 2 decimals, dot 2f. We mentioned it's because of 2 decimals. Then the coordinates of the point to annotate, same as the point being labeled. Then we are having specifying the coordinate system for the text position. Then we are having the 10 to the right and 10 to the down pixels. Then we are having the alignment. We can say center, for example, here. Okay. Then we are simply just having the show function to show the final plot for us here. So in this video, we not only reviewed certain concepts that we already learned, we also learned about how the annotate function works in Python using the Matplotlib library. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to handle large data sets efficiently. Here we are assuming that we are having like 5,000 points and we need to optimize it. How to do that? Here we are generating 5,000 x coordinates and 5,000 y coordinates, and then we are having the plot size. Here we are saying 10 by 10 inches by 6 inches. Then we would like to plot it. So first of all, let's go and see the plot. You see that it's a huge data set. So we are having a lot of points here. Okay. So when we are having a lot of points, because we want it to be easy to trace and understand the graph, because understanding the graph is also very important. Here we are plotting the scatter plot. We are having the x and y axis. We are having the size to be very small because we want to fit all the points there. So if I have a size that is big, it's not very nice to have it. You see, you cannot understand anything from this point, this figure. You see, it's not beautiful. But if we are having the size that is small, it's much easier to work with the figure. So you see that, okay, I can see points in different places. So this place is, for example, empty. This place is empty. And there are certain places that we are having overlap. You see here, this area, we're having a lot of overlap, sorry. So we need to also interpret our figure and understand it and explain it. So we reduce the size very much, and we are going to have the alpha to be 0.2 because it increases the visibility and overlapping, okay? So when we are seeing all the points here, if we see that they are not very transparent, it means that, okay, it's 1 point or 2 point. But when we are seeing the overlaps here, they are more transparent. So we can easily trace the transparency and overlapping here. So the transparency here, for example, is not is shown as 0.2 in this figure, and here you see, okay, there is 1 point, 1 point, 1 point. But here, because we are having the transparency modified to be 0.2, we can trace the overlap easily rather than having it, for example, to be 0.9. You see, everything is very transparent, and the color is very strong, so you cannot understand the overlaps. But when we are having, for example, 0.2, we can trace it very well. We can trace it very, very well. Okay. So these are the technical things that we learn by time to, for example, reduce the size and how to, set the transparency level at a point where we can trace the overlaps, because understanding the figure is something and plotting the figure is something else. So we need to plot the figure that is nice and it is understandable and explainable. Now the figure has something to say, but if we were having the transparency level to be high or the size to be high, it was not possible to get anything out of this photo. Thank you for watching. Hi, welcome back. Here we are going to discuss how we can have two data sets in one scatter plot. First of all, we're importing the necessary libraries. Then we are having the figure size. Then we are generating X and Y. And we are plotting the first scatter plot. So X and Y with the size of 10, the color red, alpha 0.7, and we label it to be data set 1. Because we are having two data sets, it's good to have a label. So we're going to use the legit function in the end as well. Then here is our second data set, x2 and y2, and we are plotting that scatter plot as well. So x2 horizontal axis, y2 vertical axis, the size, the color is blue. So previous one was red and now it's blue, so it is distinguishable. Then we are labeling it to be data set 2. So when I run this code, we see here is our figure. So the red points are the data set 1 and the blue points are the data set 2. For example, it could be the insight to have, for example, from this figure. For example, if we want to have two data sets, the red one could be the last year sale and the blue one could be this year sale. So we can now compare how was the reaction of the last year as compared to this year. For example, this is just an example to saying that we can have two different data sets and start comparing them in one figure. So here we can see how we can consider having two data sets in one scatter plot. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how we can highlight a specific point. Here we are randomly generating 50 x and y coordinates. Then we are having the scatter plot. The x-axis, the y-axis, the size of each point, and then the color we are saying gray, and the transparency level is 0.5. Now I want to have the scatter plot again to be called. So the scatter function is called one more time in order to have a highlighted point. So I would like to have the point 10 to be highlighted with the size 300, sorry, and then with the color red, we are having the edge color black, and we are going to label it. And using the legend function, we can show this label in the figure. So when I run this code, we see that all the points are in gray. However, there is one point here that is highlighted point. So this is the work of the legend here that we see. So if I comment this legend, we see that only the highlighted point is there. We are not having the legend anymore. So let me get it back. So when I run the code, we see that, okay, highlighted point, and we are having the highlighted point here, and we are having the edge to be black. So we could have the edge to be green, for example. This we can change. You see that it's green. Of course, we can change the label. For example, we are saying that highlighted point, but we can change it to anything that we want. And basically, this is how, when we want to, for example, highlight the 10th point. If you want to highlight the 20th point, you simply write down 20 here and also here. Then you increase the size of that specific point and you change the color so you can trace it easily among the other points. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to plot a scatter plot that is 3D, so three-dimensional scatter plot. Here we are generating three dimensions like x, y, and z. So z is for the third dimension. We are generating 50 numbers between 0 and 1. Then here we are having the size of the figure. Here is the size of the figure. We are saying 8 inches by 6 inches. And basically here we are just adding a subplot function and tell the Matplotlib library that we are going to have a 3D function. Sorry, a 3D scatter plot. Then we are having the scatter function here with the AX prefix. So AX dot scatter. Then we are having the three dimensions. So x-axis, y-axis, and z-axis, with each point having the size of 100. And C, which is the color, equals Z equals Z, and Y we are equaling to Z because previously we learned that if we want to have unique colors for each point, we need to have 50 numbers that are generated randomly, and then we use that to assign it to color map, and the color map will assign a unique color to each point that is randomly generated. So here we could also do that, but instead of that, we are simply assigning the color to be equal to the numbers generated for the Z that are also random. And then we are going to use those values in the color map, and we are going to use the cool warm color, and the alpha, which is the transparency level, is 0.7. And finally we are labeling our axis here. Okay, so when I run this code, we see that here we are seeing a three-dimensional figure of our scatter plot, which is very attractive. And we see that for the x-axis, for the y-axis, and for the z-axis, we are having numbers between 0 and 1. And as you see, the colors are unique, so they are on a scale bar. So we are having the cool warm color map. So the values that are assigned for the color are used in the color map to generate each point a unique color using the cool warm color map. So here we see that the figure is much nicer when we are having it in 3D. So in case that you're looking for a 3D figure, this video is for you. So you can simply use the add subplot function to tell the matplot that you're looking for a three-dimensional figure and assign it to ax, and then use that ax to call the scatter function and label the axis. Thank you for watching.
Hi, welcome back. In today's video, we would like to talk about bar charts. Here, first of all, we are importing the necessary libraries. In order to have bar charts, we need categories and values. So here I'm labeling for my bar chart categories. For example, labels for the x-axis categories A, B, C, and D, and E. And also we need to have values for each category. For example, the height of the bar is the y-axis values. And here for the category A, I'm going to have the value 10. For B, I'm going to have 20. For C, I'm going to have 15. For D, I'm going to have 30. And for E, I'm going to have 25. So these are the basics that I need to plot a bar chart. Then here is how we can have the size of my figure. For example, here I'm having 6 inches by 4 inches, and we can modify it. We can, for example, have 8 inches by 6 inches. And the first number is the wide, and the second number is how tall our figure is. In order to plot the figure, we use the bar function. Then we have the category as the x-axis, values as the y-axis, and then the color. For example, here I choose to have sky blue. We have the edge color and line width. And finally, we are having here the title. For example, here I'm saying basic bar chart example. We are having the font size. We are having the font weight. So I want to have a title which is bold. Then we are having the label for the x-axis, which is categories, and we choose the font size. Then we are having a label for the y-axis, which is values, and we are having a font size, sorry. And finally, we are displaying the chart. So when I run this code, we are having this chart. So the x-axis is categories, the y-axis is values, and this is the title of my figure, basic bar chart, and the font is larger as you can compare with this as compared to this one. It's larger, and also it's bold. You see that it's bold. This one and this one, both of them, they're not bold. But how we draw that? So we said that we need categories and values. So on x-axis, we are having the categories from A to E. And on y-axis, we are having the values. For example, we mentioned for category A, we are having the value 10. So this is category A, value 10. Category B, value 20. Category B, value 20. Category C, value 15 here. Category D, value 30. And category E, value 25. So these are the corresponding values to our categories. And one thing to mention here is that we use the bar function, x-axis, y-axis, then the color, and we are having the edge color. You see that there are edges here. So this is black. I can have it to be red so it's more identical, for example, you see. So you can choose this color as well. This is black, and you can discuss the line width. So the edge width is 1.5 now. It can be 4, for example. So you see that it's thicker now. So it depends on what we are looking for, but we can modify this as well. So in this video, first of all, we learned about bar charts and how to plot them, that we need categories and values, and then we need to have, for example, the categories and values to be x-axis and y-axis. We learned about the edge color and the line width, and also we learned how to make the title of our figure to be bold here. Thank you for watching. Hi, welcome back. In today's video, we're going to discuss bar charts, but they are more customized. Here we are importing the libraries. Then we are having the categories and values. Here we see the categories and values. We are having 5 categories and 5 corresponding values. Here I set the size for my figure to be 8" for the width and 6" for the tall. Then we would like to plot our bar chart. In order to do that, for the x-axis I have the category, and for the y-axis we are having the values. In order to choose the colors, we can simply choose one color. Like the previous example, we can say sky blue, and all of the bars will be in sky blue. However, because we are having 5 categories here I inserted 5 different colors: red, green, blue, purple, and orange. So A is going to be, for example, red, as you see here. B is going to be green. C is going to be blue. D is going to be purple. And E is going to be orange. So they're going to take these colors. We learned that edge color will be black, and this is the keyword that we can have it. So you see the edge colors, it's black everywhere. And the line width is 1.5, and we can change it. We change it, for example, we can change it to 5 if we want to test. For example, here you see it's thicker now, but it's not that beautiful. So we go back there, but you can play with this number to get to a number that you like. We discussed the transparency adjustment, which is 0.7 here. And finally, we can have different line styles here as well. So I would like my line style to be dashed. When I have the line style to be dashed, you see that we are having dashed line here, for example, in this example. And in case that we want to have, for example, solid line, we can have the solid line. Then we can have the dashed line again here. We can have like this dotted line. So it depends what we are looking for. We can always play with it. So for the moment, I keep it to be dashed line. And finally, we are having the title of the figure, which is with font size of 14, and it's bold, you see. And for the values and categories, you see that we are having categories and values, and the font size is 12 for both of them. In fact, this is how we can have a more customized version of our bar chart. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to have text annotation to each bar. So look at my figure now. We see that for category A, we are having the value 10, and this 10 is written here. B is 20, and 20 is written here. We're going to learn how to have them on our bar charts. So first, we are having the categories and then their corresponding values. We are having the figure size, and we are here plotting our bar chart. So category, values, color, edge color, and line width. So edge color is black, and the line width is 1.5, and the color is light coral. Okay, so now how can we add these numbers there? In order to do that, we need to have an iteration over the bars. Okay, so this is the bars that we are trying to create a bar chart with different colors and style. So we are assigning it to bars, and then we are iterating through that bars. Okay, for that we are going to have for each iteration, so we are going to have 1 2 3 4 5. We are going to have 5 iteration. Okay, because we are having 5 categories, we are going to have 5 iteration. For each bar that is in bars, we're going to add the text annotation to each bar. So we are going to get the x and get the width divided by 2. Why? Because the value of x is usually on the left side is this part, and this is the width of our bar. When we divide this width by 2, we will get a number. For example, this width is, for example, 20. When we divide it by 2, we see that it's 10. So 10 is this middle point. So 10 is added to the value of x, which was this point. So x plus 10, it will be in the center. This is why we are having it in the center. So the x coordinate of the text that we want to have is here in the center. Let me say it one more time. When we are having the x coordinates on the left side of the bar, it's here. Then we are going to add this x value to the half of the width of our bar chart. So this bar is having, for example, 20 as the width. The number of width is 20, okay? The size of the width is 20. So 20 is divided by 2 will be 10. So 10 means that if we start from here and we go 10 units to the right, we reach here in the center. So this 10 is added to the x, which was already here. Then it means that we are getting to the center. Okay, x, which was this point, plus this part. It will help us to get to the center. So this is how we calculate the x. Then we need to calculate the height. So we need to have the y coordinates to get to the top of the bar, So the x is here. We get the y, so y is 10, so we get to the top of the bar here. We don't want, for example, this number here. We don't want to show it here in the middle. We want to show it on the top. This is why we get the height, which is the y coordinate. Okay. Then we are going to convert the bar height to a string to display it. Okay. We're going to get the height of the bar and convert it to a string using the str because we want to display it. We're going to get this number, this 10, and convert it to a string to display it. And this is converted to a string now, this number 10 to display it. Okay. So this is what we're going to do there. And finally, we are having the horizontal alignment to be center. So the text horizontally relative to the bar. So this is the center. We can change this one to left, for example. If I change it to left, so you will see that it's not in the center. It's now left alignment is there. And we can have it to right, for example. You see it's here. Okay. But if I put it to center, it's much nicer, I think. So I put it to center. So when I recompile, we see that now, okay, it's in the center. Then we are having the vertical alignment, and we want it to be in the position bottom. So the text is slightly above the top of the bar. You see, it's slightly above. So if I type down, for example, center here, we see that it's in the center, but it's not that much nice. We want it to be a bit on the top. So in order to be on the top, we need to write down the bottom keyboard. If I write down top, we see that it goes down. So this also we don't want. We want to have the bottom. So when we write bottom, it goes slightly up, which is exactly what we want. Then we are having the font size, we want it to be 12, and then we are going to have the font weight to be bold. So you see it's bold. Basically, this is how. So for the first iteration, all these things are done for this to print this number 10. Then we go for in the next iteration, we go for category B, we do the same, category C, we do the same, category D, we do the same, and category E, we do the same. So let me review what we did one more time. Here we are having the category, we are having the values, we are having the size of the figure, and we are having our bar chart being created. Okay, and we are assigning it to bars. In order to have the text annotation, we need to have a for loop for each bar that are in bars. We are going to use the text function. We are going to get the value of x and add the width of the bar chart divided by 2. For example, here, if we want to get to the center where exactly this point is, we need to have the x value, which is this point, plus this part, okay, plus this part. And this part is half of the width. Okay, this is why we are having x plus half of the width of the bar. X plus the width divided by 2, which is half of the width. Then we are going to have the height, so we know how far we are going to go up. So the height of the bar chart is also there. So we are here now, we know the height. Then we are going to get this value of the bar chart, which is 15, and convert it to a string to be able to display it here. So this 15 is a string now that is converted from this 15. And then we are going to have the horizontal alignment and vertical alignment, the font size, and we want it to be bold. Finally, we are having the title of the chart. We are having bar chart with data labels. We are having font size, which is 14, and we are having it bold. Then X label and Y label is also their categories and values. And the font size is 12. So basically, this is how we can have a very nice bar chart, and we can have customized text annotation for each bar. Thank you for watching. Hi, welcome back. So far, we learned how to plot our bar charts, but they were vertical. Now in this video, we are going to learn how to plot our bar charts that are horizontal. In order to do that, first of all, like always, we are going to import necessary libraries. Then we are going to have our categories A to E, their corresponding values 10 to 25, for example. And here is my figure size. The main difference comes here. So here, what we want to do is the following. Instead of having the bar function, we are having bar h function, meaning that a bar chart that is horizontal. So bar h function, we are considering categories and values. The color is teal. This is the color that I choose. We can choose whatever we want. We are having the edge color black and the line width 1.5. Then I'm labeling the title. Like always, we are labeling the x-axis. This time the x-axis is values and the y-axis is the category. So when I run the code, we see that now on the x-axis we are having values. On the y-axis we are having categories, and we are having from A to E here. Okay. And this is the color that I choose. It's teal, so we can change it. This is the edge color, which is black, you see here. And the line width is 1.5. We can customize it, of course. And basically, the main difference in plotting the bar charts that are vertical and horizontal is the function that we use when we want to create them. So if we use bar function, it's going to have a bar chart that is vertical, and if we are having the bar h, it means that we are looking for a bar chart that is horizontal like this one. Okay, previously we were having our bar chart like this from here. Thank you for watching. Hi, welcome back. In today's video we are going to talk about grouped bar chart. Here is my figure. So we are having grouped bar charts. So we are for A, we are having 2 bars. For B, we are having 2 bars. For each of them, we are having 2 bars, and we are having 2 datasets, dataset 1 and dataset 2. So dataset 1 is the blue bars, dataset 2 is the, let's say, the orange bars. Okay, so how can we do that? It's very easy. We can have the categories. It's shared because we are having, for example, 2 bars for category A, 2 bars for category B. So it's shared. We can have A, B, C, D, and E. But each category has different, each dataset has different values. For example, in the dataset 1, for the category A, dataset 1, we are having the value 10. But for the same category in the dataset 2, we are having the value 5 here. Sorry. So for example, for category B, we are having 2 datasets. One value is 20, one value is 15. So exactly here, the value 1 for category A, for categories, for A, B, C, D, E, and value 2 for these categories. So for example, A, if in value 1 is dataset 1, it's 10, but in the dataset 2, it's 5. So A for dataset 1, which is the blue, is 10. For dataset 2, which is orange, is 5. So we are having 1 categories and we are having 2 datasets. Okay. Now we need to have our X. So first of all, here, this part, the len function, and inside parentheses, we are having the categories, is going to return the number of categories for us. Okay. So the number of categories, which is 5. And we are going to have the number of categories, and then this part, the whole part, is going to generate an array from 0 to 4 with indices from 0 to 4 for 5 elements, which assigns a unique number index to each category. Okay, so we are going to have unique numeric index to each category A, B, C, D, and E. So this is what it's going to happen here. Okay, then we are having the width of our bars, which is 0.3. So you see the width is 0.3 now, 0.3. So we can change it to what we want. We can have 0.2, for example. It's changing. We can have 0.1. We see that it's like this. We can have 0.4. So this is the width. Whatever we want, we can choose. So I choose to be 0.3. So 0.3 is good. Now we are having the size of our figure. So it's 8 inches by 6. So I would say 6 by 4. So it's a bit smaller now. Okay, so it's easier to see in the monitor. So now we discussed the figure size as well. Now we need to have the bar function. So in order to have the bar function, we were having the x here, the x-axis, let's say, the y-axis, the width we are adding here. This is the width of our bars. We are having the label, we are having the color, and we are having the edge color. So edge color is black. And what is happening here? So for the first data set, which is this one, we are having x minus width divided by 2. And for the second one, we are having x plus width divided by 2. But why do we need to have that? Let me remove this one so we see the difference. So when I run, we see that we are having overlaps. So these bar charts, the bars that are blue, you see that they are overlapping because A is in the middle now. Okay, so A is the starting point of the orange because we are still having the plus width divided by 2, but A is having the overlap. So, and it's not very nice to have them like that. Okay, so if I also, let me put it here. So if I also remove this part and I run the code, we see that we are having the full overlap. So this is another way to have the bar charts, but this is not what we were looking for now. So in order to make them nice, you see that they are overlapping fully here. We want to have the second data set to move a bit to the right, and the first data set, which is the blue one, to move a bit to the left. So the orange one a bit to the right, the blue one a bit to the left, and this happens to all of them. So this orange a bit to the right, and this blue a bit to the left. In order to do that, we calculate the half of the width. So this is the width, okay? This is the width, and this is the center point. We are going to shift the orange one half of the width to the right, and shift the blue one half of the width to the left. So they will be next to each other exactly. I will say it one more time. So I'm going to shift the orange one as large as half of the width to the right and half of the width to the left for the blue bars. Why? Because this way we are going to have them next to each other instead of both being this to the center. So it's like the center of the blue will be this point, and the center of the orange will be this point. Okay? So this is the ending part of the blue and the starting point of the orange. So this is why we need to have them here. So when I run, you see that, okay, so A is the center still, but it's the ending point of the blue and the starting point of the orange. So the blue has shifted half of the width to the left, and the orange has shifted half of the width to the right. So this is how actually we can make them nice and clear. But we could also have the overlap version if you prefer, of course. So this is the bar chart for the first data set. We shift the first bar chart a bit to the left and the second bar a bit to the right for the second data set, let's say. And this one, again, we are having the X, the values, the width, it's the same. The label is data set 2, and the color is salmon. So you see the color is salmon and not orange, let's say. I didn't realize that it's salmon. To me, they are both the same, but their name at least is different. Then we are having the edge color, and this one is also black. Okay. So then we are having the set category names on x-axis. Here we are having A, B, C, D, and E. Okay. So we are using this x ticks function to have the x-axis to have the name of our categories A, B, C, D, E. Then we are having the group bar chart title, the font size, and we want it to be bold. Then we are having the X label, which is this category, and the values. Okay. And we are having, of course, the legend, because we were having the labels here. We want to show the legend here. So this is the legend that we are seeing here. And finally, we are having the show function in order to display our grouped bar chart. So the only thing that we need to be careful is how we are managing this X part. And also, if we want to have the names on X axis, we simply use the X ticks and we are writing down the X axis and then categories to be printed there. So this is how we can have a very nice grouped bar chart. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about stacked bar chart. What is a stacked bar chart? We are having two data sets, dataset 1 and dataset 2. Dataset 1 is shown in blue and dataset 2 is shown in, let's say, reddish orange, something like this. So we see that the dataset 1, for example, for category A, we are having here, the value is 10. For dataset 2, the value is 5. So for the dataset 1, the value of category A is 10. For the dataset 2, the value of category A is 5. So let's go back there. So in a stacked bar chart, we are going to have the category A. So for the first dataset, the value was 10. So the starting point is here and the ending point is at 10, because the value for category A in dataset 1 is 10. However, in the second dataset, the value was 5. But here we are going to start from here. So the starting point of the second dataset is the ending point of the first dataset. Okay. So we are going to start here and we are going to finish at 15 because the value is 5. So 10 plus 5, it will be 15 here. Okay. So this is what we call stacked bar chart. When one data set starts at the end of the first data set, the previous data set, let's say. The same goes with the other categories as well. So D, for example, the starting point is 0 and the value is 30 because it finishes at 30. However, we see that for the second data set, it starts at 30 and finishes, I think, at 55. Yes. So the second data set, we are having D. So D here is 25. Yes, exactly. So it starts at 30, it finishes at 55. So 55 minus 30, it will be 25, which is the value of the category D in the second data set. This is how a stack bar chart would work. So how we can illustrate that? We import the necessary libraries first of all. Then we are having the categories, we are having the first data set, and we are having the second data set. For example, for the category C, in the first data set, we are having the value of 15, but in the second data set, we are having the value of 10. Then we are having the figure size to be 6 inches by 4 inches. So this is the size. I think it's a good size for showing it in my, for example, monitor. Then we are going to have our bar function to plot the bar charts. First, we are having the categories and value 1 and categories and value 2 for the first bar chart and the second bar chart for the, let's say, the bars for the first data set, let's say, and the bars for the second data set. So here is category and values 1 for the first data set, and then categories and values 2 for the second data set. Here we label data set 1, we consider the color and then the edge color because they're black, so we consider it to be black. Here we are also labeling it, we are having the color and we are having the edge color as well. However, we are having this as well. So this part of the code is mentioning that the bottom part, the bottom point of the second data set should be equal to value 1. It means that it should start at the end of value 1. Okay. So instead of starting from here, from the x-axis, it is going to start from where we are having the value 1. And what is the value 1? Here is it. It is. So for example, for category A, the value 1 starts from 0 and it goes up to 10 because the value is 10. And now this 10, which is the value 1, is the starting point for the second data set. So this 10 is the starting point for the second data set, as you see here. Okay. So we are having the bottom to be value 1. And value 1, these are the values 1 for each category. For example, for the B, when we want to plot the second data set, the value for the data set 2 for category B is 15. Okay, but we are saying the bottom line, the starting point should be equal to value 1, which is 20. Its corresponding values 1, which is 20. So for category B, we have the value 15 and its starting point is 20. So B, the starting point for the data set 2 is 20, and from there we are going to have 15 units. So 20 is here, and we are going up 15 units, which will be 35. So this is how we can have the stack bar chart. Then we are having the title, we are having the font size, and we are going to make it bold. So we are having the title and the font size is 14 and we are having it bold, and here we are labeling the x and y axis. We are having the legend being displayed, this part, because we labeled our plots, our data sets, let's say. And finally, to display the figure, we are having the show function. It was how to draw a stacked bar chart in Python using Matplotlib library. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about bar chart with error bars. Here with bar chart with error bars. We are having the bar charts and we are having caps for the errors. Okay. So how can we draw this? In order to draw that, first of all, we are importing the necessary libraries. We are having our category and our data set. For category A, we are having the data set of 10. For category B, we are having the data set value to be 20. For C, we are having value 15. For D, we are having value 30. And for E, we are having value 25. Then we are having the figure size. We want to have a 6 by 4 figure. Then we are having here the errors. Okay, these are the error values. For example, for the category A, the value is 10, but it can have 2 units of errors, either above 10 or lower than 10. Okay, 2 units above, 2 units lower. So here in A, we are having the value up until 10, but we are having the cap starting from 2 units lower than 10, which is 8, until 2 units after 10, which is 12. So from 8 to 12, it is there, the cap. Okay, so this is how we can consider error bars. For example, for category B, we are having values 20 and we are having the errors of 30. It means that it can go to 23 or it can have as low as 17. So when we come here, we are having the value of category B, which is labeled at 20, but we are having 3, the value of the error is 3. Okay, so it can go from 20, it can go up to 23, which is here, and it can go down up to 17, which is here. So we are having the cap here. So in order to draw that, first of all, we need to have the errors. So error values we need to have for each category. We are having 5 categories, we are having 5 values, and we are having 5 errors. Okay. Then in order to integrate the errors, we call the bar function. As always, we are having the categories and values. Then we are having the YERR equals errors. So this is going to add vertical error bars to the bar in the chart. Okay, this function, actually, this part of the bar function is adding these vertical caps. Okay, these vertical error bars you see here are added by this part of the code. Okay, so YERR equals to errors. So errors, we define it here. So we are assigning it to be here to the year, let's say, and this is how it's going to help us to have the error bars here. Okay, then we are having the cap size. This cap size is going to help us to have the horizontal size of the cap. For example, now it's 5. If I have, instead of 5, if I have 50, we see that here they are much larger. So, okay, you see now the difference, the horizontal size of our cap. Now it's too big, I think. So let's go back to 5. So we see now, okay, it makes sense now, but you can customize it as you wish. So this part is going to have the vertical error bars to the bar in the chart. And the values in the error specify the length of the error bars for each category. Okay, the value of the error is going to specify the length of error bars in each category. Then this part also is going to help us to have the size of the horizontal caps at the end of the error bars. Make it more visible, let's say. Then we are having the color dark orange. Okay, and edge color is black. So edge color is black. So this is how we managed everything. And we are having the title, we are having the x-axis title label, let's say y-axis label, and display function, which is show. Okay, show function, which is going to display the chart for us. So this is how we can draw a chart, a bar chart, let's say, with error bars. Thank you for watching. Hi, welcome back. In today's video, we are going to work with bar charts with logarithmic scale. So we see here in the y-axis, we are having logarithmic scale. But how do we have that? Here is the categories, but here is the logarithmic scale. We are having a bar chart with logarithmic scale, and these are our categories and values. In order to have them, we are having the libraries being imported, of course. We are having the categories A to E, and we are having the data set here. And again, we are having the size of our figure. Then we are having categories in the bar function to plot our bar chart values. We are having the color sea green, which is a new color that we are seeing in each example. So in each example, we try to have a new color so you can also get used to and get familiar with different colors that you can use here. And then we are having the edge color, which is black. So the edge color, it's black. So in order to have the y-axis to be like a logarithmic scale, we simply use the y scale function, and we are going to write down this keyword, log. Okay, this is going to convert our y scale to a logarithmic scale. Then we are having the title of the chart. Then we are having the x label and y label. So the x-axis label, y axis label, and then we are having again here we are having the y label to be values here as we are showing it here. Okay, but we can also comment this part. So if I run the code, we can have the y label because we don't have to define it twice. We can have it once. When we are having it defined twice, the second one will be effective here. So now that I commented this part, we see that log scale values is the final label that we are having it here. And in this part, we see that the x-axis has the label categories, and this is the title of the figure bar chart with logarithmic scale. And these are the categories A to E with different values that are shown here in our bar chart. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about histograms. Here is my histogram. This is a basic example of histogram in Python using Matplotlib library. We see that we are having beans here, okay? And this is the frequency. And to generate values, we use the normal distribution. That is why you see the bell shape here. And how can we plot this histogram? First of all, we need to include the libraries, as always. Then we are going to have generating the random data. So this is my data variable. We are going to randomly generate values and 1000 random values, let's say. And we are going to use the normal distribution. So rand n means that normal distribution. We are going to have a standard normal distribution that is going to generate 1000 numbers for us, okay, and assign it to data. Here is my size of the figure. So I have it 6 by 4 because it's easy to see it here. Maybe even we could make it smaller if you want, 5 by 3, let's say. Okay, now it's even better. So you can have your scale here. Then in order to build the histogram, we are going to have the hist function, HIST. So we are going to use this function. First, we are going to have the data that we generated for 1000 random values from a standard normal distribution. Then we are having the beans equal to 30. What does it mean? Beans means the units that we are having in the x-axis. Okay, so we are having 30 units here, 1, 2, 3, 4, 5, 6, 7, etc. Until the end, it will be 30. So we are going to have 30 beans here. Okay, then we are going to choose the color. We are going to have the edge color. So the edge colors are black, and the color is sky blue, which is a very nice color, by the way. And that's it. We can have our histogram. Now let's have a title, basic histogram example. This is my title, font size 14, and it's bold. Then we are having the x-axis label, y-axis label, and we are showing it and we are displaying it. So when I run the code, we see exactly here what we have explained. So this is a histogram, and we are having 30 beans here, and this is our frequency. For example, number for this zero part, we are having a lot of frequency. For value, for example, -2, let's say, we are having lower amount of frequency because it's like a bell shape, because we used a standard normal distribution using the rand n function. Thank you for watching. Hi, welcome back. In today's video, we're going to work with histograms, but we would like to customize it a bit so we can have colors, transparency, and edge styles. Here, we are importing the necessary libraries. We are having 1000 numbers being generated using the standard normal distribution using the rand n function, and we are assigning it to our data variable. This is the size of my plot, and simply because we wanted to plot a histogram, we're going to use the hist function. This is the data. This is number of beans that we are going to have. This time I choose to have 20 beans. So 1, 2, 3, 4, 5, 6, 8, 9, 10. Until the end, it will be 20. Now we choose the color, which is purple. We choose the edge color, which is yellow. You see the yellow edges. And we are having the line width to be 1.5. We can change it, of course. We can have it to be 5. We will see it will be very thick. So you see that it's not beautiful anymore. And let's choose a good number so it's beautiful. Okay. Then we are having the alpha, which is the transparency adjustment, and it's 0.7. And you see it here. We can, of course, change it to, for example, 0.3. So you see that it's less transparent. So let's go back to 5. Let's say I think 5 is a good one. So we go with 5. Then we are having the line style, which is dotted. So you see that it's dotted. It's not a solid line. This is how we customize our histogram. Then we are having the title, we are having the x-axis, and we are having the y-axis. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to adjust the number of beans. Here I'm having 3 histograms in one plot, and you see the number of beans are different. So for the first one, we are having the purple one, we are having the 10 beans. Then for the second one, we are having 20 beans. And for the third one, we are having 50 beans. Okay. So there are different number of beans distributed here. So let's see how this is possible and how we are doing it. Okay. In order to do that, first we import the libraries. We generate 1000 random numbers from a standard normal distribution. Then this is the size of my figure. So this is the size of my figure. Then I'm having 3 histograms, hist, hist, and hist. Okay. All of them are having the same data. So the same data is used. The same variable, let's say, is used. But in the first one, we assign the number of beans to be 10. In the second one, we assign it to be 20. In the third one, we assign it to be 50. That we see here, 10, 20, and 50. We are having the same level of transparency, 0.5 for all of them. Then we are having the label 10 beans, 20 beans, and 50 beans, as we see here in the label. So we are using the legend function as well, because we see the legend here. So we are separating the histograms based on the beans. Now we are having the color blue, red, and green. So blue, red, and green. And the edge color is black for all of them. So edge color is black for all of them. Then we are having the title of the histogram here. We are having the x-axis label, the y-axis label, and finally the legend function and the show function to show us the figure. So this is how we are having three uh, different histograms based on one data, but because their bins are different, we see that they are different here. They are shown differently here. So the number of bins is very important, and in this example, we wanted to show you that how the number of bins can vary the shape as we see here. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about how to plot a normalized histogram, or let's say density plot. We are going to have two libraries as always. We are having 1000 random values from a standard normal distribution being generated and assigned to data. Here is my size. As you see here, I am using the hist function to plot my histogram. So I'm having the data, I'm having the number of bins, I choose 30, I use the color teal, the edge color, which is black, so the color teal, the edge color, it's black, and the alpha, which is the transparency, it's 0.7. However, in order to make it normalize, you need to add this part. Density equals true. When you are assigning density equals true, it is going to normalize our plot, okay? And here again is the title, here is the x-axis label, and now here is the density, okay? So this is the label for the y-axis. Y-axis is now a probability density as not frequency, okay? The probability density, this is the y-axis because we are using density plot and we are normalizing our histogram. This is why the y-axis is not frequency anymore, but it's the probability density. Okay, and in this video we learned how to have a normalized histogram simply by adding the density equals true. Thank you for watching. Hi, welcome back. In today's video we're going to learn how to add kernel density estimation curve. So this is my histogram, and you see that this blue curve, this is my kernel density estimation curve, or we simply call it KDE. And KDE is a way to draw a smooth curve that shows where points are mostly packed together, okay, or mostly packed together. It's a way to draw a smooth curve that shows where data points are mostly packed together. So this is KDE curve, okay? And it spreads each data point like a small hill and it adds them up to make a continuous shape. So in order to draw this KDE curve, we first of all have to import our NumPy and Matplotlib library. Then we are having the importation of Seaborn for the KDE plot. We're generating 1000 random values from a standard normal distribution. And then we are going to use the Seaborn library to call the histoplot function. We are having the data, we are having the number of beans, which is 30 here. And here, in order to add the KDE curve, we simply have to write this KDE equals true. So KDE will be added automatically. We're choosing the color and edge color, which is black here. Then we are having the titles. We are having the titles here. Histogram with KDE curve. We are having the x-axis title, and we are having the y-axis label. Here is the density. So in this video, we learned about kernel density estimation curve, and we learned how we can add it to our histogram. Thank you for watching. Hello and welcome. In today's video, we're going to learn how to plot a cumulative histogram. This is my cumulative histogram here. We're going to learn how to plot this in Python using Matplot library. First of all, we need to import the Matplot and NumPy. We're going to generate 1000 random values from a standard normal distribution. And then we are going to have the hist function to plot our histogram. Then we are going to use the data. We are going to use the beans. We are going to choose 30 beans here. Then we are going to have the color, which is navy, edge color to be black. Then the transparency adjustment, which is 0.7. And in the end, we can have the cumulative keyword equals true. When we are having the cumulative keyword equals true, we are going to have our cumulative histogram. So if I want to not to have a cumulative histogram, we can simply remove this keyword and we will see that we are going to have a normal histogram. But if we are looking for a cumulative histogram, this keyword will be helpful to be assigned to true in the hist function when we are building our plot, and we see that this is a cumulative histogram. And this is again our title, x-axis label, and y-axis label. Thank you for watching. Hello and welcome. In today's video, we're going to learn how to plot a horizontal histogram. Here, in order to have a horizontal histogram, first of all, we're importing the libraries. We are having 1000 numbers, random values to be generated following a standard normal deviation. A standard normal distribution. Then we are having the size of our figure, which is 5 by 3, which is a good size to show here. And then to plot our histogram, we use the hist function. We are having the data, the beans, the color, we choose olive. You see that this is the olive. And edge color, which is black here. And then we are having the orientation equals horizontal. So by adding this keyword, you're going to have horizontal histogram. So orientation equals horizontal. Orientation equals horizontal. This is what we need to add to have a horizontal histogram. Then we are going to label the x and y axis and also having the title. In each example that we are giving you here, we are adding one new point to be learned for you. So here we are having the orientation, for example. It's one simple point to be learned. But whenever we want to teach you one single point to learn, it's very good to start again from the beginning. So I'm going to say, okay, import these two libraries, generate random numbers, have the size of the figure, because you're going to hear it again and again, and it is going to for you becoming normal. Okay, for the start, we must include the libraries first. We must import them. Then we are going to generate. So you're going to understand the steps that you need to take each time when you are plotting a figure from the beginning until the end. And one changes can have a totally different result, as you see here. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to have a y-axis for our histogram with logarithmic scale. Here we are going to import our libraries. Then we are going to generate 1000 random values from a standard normal distribution. Then here we are going to have the figure size 5 by 3, 5 by 3. Then we are going to use the hist function in order to plot our histogram. Here we are having the data, the beans, the color. I choose steel blue this time. Then edge color, which is black. So the edges, you see that it's black. And now we want to have y-axis to logarithmic scale. Therefore, we are having the y scale function. And then we are having the log here. So it is going to change the normal scale here to a logarithmic scale. Here we are again having the title of the figure, and then we are having the labeling of the x-axis and y-axis, and here we are using the show function to display our figure. So in this video, we learned that by including this line, we can have our logarithmic scale for the y-axis. Thank you for watching. Welcome back. In today's video, we are going to learn how to draw a basic pie chart in Matplotlib, okay, using Matplotlib library. So in order to do that, first of all, we're going to import the library that is necessary for plotting, which is Matplotlib library. Then we are going to discuss the sizes representing the portion of the whole, okay, and also the sections. These are the sections that we have. For example, A, B, C, and D. These are our sections. And for example, we are saying that section A has 30% of the portion. So this is the 30%, the blue part. We say that, for example, section D has 15%. Section D is the red part. So it has the 15% of the whole portion. This is how we need to have the sections, or let's say label for each section, and values representing the portion of the whole. Okay. Then, as always, we are going to discuss the size of our figure here. The size of our figure is here. So we are having a figure 4 by 4. And finally, to plot our pie chart, we are going to have the PIE function. Then we need two arguments here: sizes, which are the portions, the values representing the portions of the whole, and the labels. So the labels that we want to give to each portion, okay? And we name it to be sections. So sections are assigned to the labels. It means that we're going to have A, B, C, and D. So instead of having the sections, if I write down something like 1, 2, 3, and 4, here we see that 1, 2, 3, and 4 are the labels for our sections. But we don't want to have that. We defined sections because we want the labeling to be A, B, C, and D. Instead of writing it A, B, C, and D here, we could directly also write it here. We could say, for example, A, B, C, and D. So if I run the code, we see the same results. But it's easier to define these labels in a section separately here, and then assign the variable name simply here. It's much easier. It improves the coding readability. We define the labels here separately. Then we are going to assign the sections to our labels here. Okay. Finally, we are having the title of the figure saying that basic pie chart example. We are having the font size, and we are having the font weight, which is bold here. And finally, we are using the show function to plot and display our pie chart. Thank you for watching. Welcome back. In today's video, we're going to work with a pie chart here that we define the edges, color, the edges width, and also we can have these numbers, the proportion of each section being printed in the figure. Okay. In order to have this customization, we have the sizes. We are having the sizes. We are having the sections A, B, C, D, and for example, A has the portion of 30, B has the portion of 20, C 35, D 15. And we also want to have a specific customized colors. For example, we want section A to be red. You see here, section A is red. We want section B to be blue. We want section C to be green. And finally, D to be purple. So we can also have colors. So I assign colors as well, and I put the name of my variable my colors. Then we want to create a pie chart. We use the PIE function. We have the sizes, the labels that are assigned to sections. So sections that we are in having here, we are having the sections name A, B, C, D. We are assigning to the labels here. Then we are having the colors. For example, to have the customized color, we need to use this keyword, and this keyword is assigned with my colors variable, in which we are having our colors, customized colors, and then we're assigning to the colors here. Okay, so in order to have the colors here, I write down my colors here and I assign it to my colors variable, and this variable is assigned to the colors keyword. So we need to have the, for example, labels keyword, colors keyword, and the labels equals the sections naming, and the colors equals the colors that I choose for each section. Then we are having the auto PCT, and basically here is the part that is helping us to have the numbers being printed on the sections. So auto PCT is helping us to have these numbers, but how it works is like the following. So this part, this highlighted part that I'm having here, I mean percentage 1.1f, is going to display the percentage with one decimal. You see, the percentage with one decimal is being shown here, and the rest, these two percentages, is going to have help us to have this percentage sign symbol in the output. So the auto PCT is what is going to help us to have the portions being printed on the sections here, like 30, 15, 35, and 20. So this first part, percent 1.1f, is going to display these numbers with one decimal and having these two symbols here. Okay, these two percentage is going to help us to have the percentage being printed on the sections, okay, after the numbers. So this is the part, and then we are having this wedge prop, in which we are going to have the edge color that is, for example, now we want it to be black. So when I run, you see that it's black. We want the line width to be 1.5. We can choose something thicker. So for example, you see that it's now thicker, but we can choose the line width here. So I choose it to be 1.5 because it's, I think, it's nice this way. And this is the color that we discussed. So the edge color can be chosen, the width can be chosen, the text, the portions of each section can be printed on them. We can have customized colors, labels for each section, and finally the sizes that we are having here. Finally, we are having the title, and we use the show function to display our pie chart. So in this video, we learned how we can customize the colors, how we can have the edge color, the edge width, and also we learned that we can print the portions of each section on the figure itself. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about a pie chart with an exploded slice. You see, this part is separated from the other parts. How can we do that? Here, I am trying to include the libraries, that matplot library that we are adding here. Then here we are having the sizes, I mean the values representing the portions of the whole for each section. And we are having also the customized colors here. So we're having red, blue, green, and purple. So for example, the
section A has 30% of the whole, and it is represented by red color. So we see that section A has 30% and it is represented by the red color. However, if we want to have one part to be separated, we need to work with explode. So the explode is going to be like this. We're going to have the explode of section A to be 0, section B to be 0, section C to be 0.2, and section D to be 0. It means that when we are having the value 0, it means that do not do anything with them. Keep them as normal. But when we are having 0.2, we see that section C is separated. So for section C, which is the third section, we are having the third number here, 0.2. You see, so this is how we can have the explode. And if I increase this number to be 0.5, we see that this part will be further away. So the distance from the original figure is much more. And if I reduce it to be, for example, 0.1, we see that it's much closer. So this is how we can adjust the distance of the separation. So I keep it as 0.2 because I think 0.2 makes more sense. It's something that we can customize. So then we are having this PIE function by which we are trying to create the pie chart with explosion. So we are having the sizes. Again, we are having the labels. We are assigning the section to the labels. We are assigning my colors, which is this one, to colors. So we are having customized color. Then we are having here labeling on the sections. For example, 35%, 15%. These numbers are added to each section using the auto PCT. And here we are having the wedge props where we discuss the edge color to be black, the width of the edges to be 1.5. However, the new part is the explode. So when we want to have an exploded slice, we need to include this in the PIE function. And it is equal to the portions that we are deciding here, okay? So what we are deciding here, 0, 0, 0.2, and 0 is going to be assigned to the explode. And when it is assigned to the explode, when we run the code, it understands that all the numbers are 0 apart from the corresponding number for the section C, which is 0.2. When it is 0.2, it means that, okay, separate the portion that is for part C. And instead of having that, if I put it to be 0 and this one is now 0.2, it means that the section D will be, exploded. Okay, this part is now having distance from the original figure, and this can change as well. So we can have this part and have, for example, this part. So we see now A is separated, D is separated, but B and C are at their place. So this is how actually we can separate these slices to have more emphasis on them, or if we want to present something specifically about one of the sections, we can using this way we can distance them from the original figure, which is sometimes much nicer. So in this video, we learned how to have the slices being further away from the original figure. And we reviewed that we are going to have, for example, the line width, the edge color, how to have the numbers and portions being printed on the sections, and also we were having the colors customized, the section names, etc. Thank you for watching. Welcome back. In today's video, we are going to learn how we can have the legend here in our pie chart. So we discussed so far that we can have the sizes, the sections, the colors, and the explode. We discussed that, for example, in this example, we are having the explode of the slice D. And Now we would like to have the legend. Because we are having the labels here for each section, we can have the legend as well. So we are having, for example, our color. The red color is A, the blue color is B, etc. until the end. We can have the legend function, the title, and the location. So here I put it to be lower left. I can have the lower right, for example. So this is lower right. We can have upper right. We can have it to the upper right and also upper left. So this is how we can position our legend. And also here is the normal situation for our pie chart. But there is a possibility so that we can rotate our pie chart. So when I run the code now, we see that it has changed. So it is rotating 90 degrees. Okay, 90-degree, it has been rotated now. So in order to do that, we simply need to have this keyword and then put the amount that we want to rotate. For example, now 90 means that 90 degrees it has rotated. And in this video, first of all, we learned how to choose the location for our legend. And also we learned that we can have the rotation of our pie chart. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to have a donut chart. So there is a empty circle in the middle, but how can we draw this? Here is our previous example again. We see that we are having the sizes, sections, colors, and the explode. Here we are not using the explode anymore, so I'm going to remove this part. Then we are having the pie chart here. So here the pie chart is what it's trying to do is the following. So it is going to have the sizes, the labels, and the colors. Then we are having the edge color, which is black. And then we are having the line width, which is 1.5. Okay. Then, because we want to have a white circle in the middle to create a donut chart here, we need to include GCA. Then we are having the add artist function. We are having to add a circle, and this is the radius. For example, we can modify this, and this is the color. So the color is white. I could say the color to be, for example, black. So when I run the code, you see the middle circle is now black. We can change to whatever we want. So it's white again, and I can modify this number as well. So I can have 0 instead of 0.5, I'm having 0.9. So you see that it's much bigger, and it doesn't make sense to have it this big. We can try 0.3. We see that it's very small now. So I think 0.5 would be a good start to have it here for the size of the middle circle. Also, we are mentioning that we want to have our circle in the middle here. You see that because we are having 0 and 0, this is in the middle. But we can modify this number as well. So if we want it to be middle, we are going to choose the 0 and 0, but we can choose, for example, 0.5, so it's a bit to the right. We can have negative 0.5 here. It will be a bit to the left. Then we can also modify this, for example, 0.2. So it's going to go a bit up because it's the y-axis. So this is the x-axis and this one is the y-axis. And we can go, for example, 0.5. So it will go up here. So it's the x-axis, it's minus 0.5, so it is coming to the left. Then it is going to the up because we are having the positive 0.5. But if I make it negative, it will go down along the y-axis. You see here, it becomes here, it comes here. So depending on what we want to do here, we are going to choose also the x and y. But for the moment, I would like to keep it at the center because I would like to have a donut chart here, a donut chart. So basically in this video, we learned how we can have the middle circle. We chose the color, we chose the size, we chose the center where the center of this uh, circle should be. And in order to do that, we use the circle function to have it being plotted here. But we should remember that we call the GCA and also add artist functions before adding the circle. So if it's hard for you to remember all of these keywords, it's not mandatory for you to remember it. You can just simply copy paste my code and then use it whenever you want and modify it accordingly. So you can, whenever you want, you can check out this code and copy this part or write it down somewhere and then paste it in your project, and you will see the output will be like this. Thank you for watching. Welcome back. In today's video, we are going to learn how to have two pie charts in one figure. Here we are having the sizes, sections, and colors. But the thing that starts changing here is how we are plotting the figure. So we need to have subplots. In order to have subplots, we are having one row and two columns. Column 1 for the pie chart 1 and column 2 for the pie chart 2. Okay, so we see it like a matrix, let's say. One row, because we are having only one row here, and column 1 and column 2. Okay, so here we are having the first row. So we are having one row here and we are having two columns. So one row and two columns, and this is the figure size. We're going to decide about these in this line. Then we are talking about the first pie chart, the pie chart that is in the column 1, which is the index 0. And then we are going to talk about the second pie chart, which has the index 1. Okay, 0 and 1 are the indexing. Column 1 with index 0, column 2 with index 1. Okay, here we are using the PIE function. We are having the size, label, color, and we are having the text on the sections. You see 15%, 30%. We are having the first pie chart has been rotated 90 degrees. Here we decide about the color edge. Here we are having the line width, so the width of the edge. And that's it about the first pie chart, the pie chart that is in the first column with index 0, and we are putting the title of this one to be pie chart 1. Then we are going to plot the second pie chart, but the second pie chart we want to have exploding. So this separation is called exploding of a slice. In order to have that, we are having the explode. Then we are this time using the index 1 for the second pie chart. We are having the size, label, color, the text that is going to be printed here, like 20%, the proportion, the portions that are printed on the sections. We are having the explode. So this is the explode that we are assigning to the explode keyword. We are having the edge color to be black and the line width to be 1.5. Then we are having the pie chart 2 title, which is here expanded. And simply in the end, we are going to call the show function to simply print us and display us the figure. So this is how actually we can have two pie charts. So in order to review, we are having one row and two columns. Okay, column 1 and column 2. Column 1 is shown with the index 0, column 2 is shown with index 1. And based on that, we are putting two pie charts in one figure. Thank you for watching. Welcome back. In today's video, we are going to not only review different charts that we learned so far, line chart, scatter plot, and bar chart, but also we are going to learn how to have these three charts in one figure. Here we are first of all importing the necessary libraries. We are having now the generation of sample data. We are having the x between 1 and 10, and the value for y, it's 2, 3, 5, 7, 11, etc. until 29. Then we are creating one row and three columns. Why? Because we are having one row is here, and three columns. Column 1 for the line chart, column 2 for the scatter plot, and column 3 for the bar chart. Okay, so all the figures are in one row. It's not like we are having one here and one here, so we don't have two rows. One row, column 1, column 2, and column 3. Now, after having this, we are going to plot our charts. So we start with the line chart. We want to have it to be index 1. So index 0 to be column 1. So column 1, index 0. Column 2, index 1. Column 3, index 2. So column 1, index 0. Column 1, index 0, we are having it here. So we use the plot function. We are having x and y. We are having the marker O. So you see we are having at each data point, we are having the marker O. Then we are having the line style, which is a solid line. So it's a solid line. The color is blue. The label is line chart. So the color is blue and the label is line chart. Okay, so we are having a legend function as well to display it. Okay, but one thing to keep in mind is that whenever we are working with different columns, we need to write down the index, okay, axis, and then the corresponding index. For the line chart, we want it to be in column 1, so we use index 0. So when we compile the code, the compiler knows that, okay, this is for the first column. Then here we are going to use the scatter plot figure, and in order to plot that, we need to use the scatter function. We are having the x and y, and we are having the color R. So the color R, which is red, is shown here. And we are having the label, which is a scatter plot. Okay. Then we are having the title, x-axis, y-axis, and its corresponding legend. So we are having the legend here. So the x-axis, the y-axis, and we see the figure is red. And this is the title. And we are having basically the same data, but this time the data is shown in a scatter plot. Previously, it was like a line chart. Okay. Finally, we are talking about the third row, which is a bar chart, and the index of this row is 2 because we start from 0, 1, and 2. And in order to let the compiler know about that, we are going to have the index 2 there and axis 2, okay? Because we created the axis here when we were saying that one row and three columns. Then we are having the bar function to plot our bar. X, Y, and color is green, and edge color, which is black. So we see the edges, it's black. And the label, which is the bar chart, and we use a legend function to show the label, which is bar chart. We are having the title, we are having the x-axis, and we are having the y-axis. So the x-axis, the y-axis, and the bar chart title. In this video, we learned how to have one row and three columns. Therefore, we are having three figures in one figure, let's say, three parts or three plots or three charts, let's say, in one figure. We are having the line chart, we are having the scatter plot, and we are having the bar chart. Thank you for watching. Welcome back. In today's video, we are going to give you a brief review of what has happened so far and give you insights over different types of charts and plots. Here we see that we are having a line chart that shows sales trend over 6 months. For example, we see that the amount of sale in the month of January is 500, in February is 700, then it's 800. We have a reduction in April,
and then it goes up again to 900 in May, and then we are having more than that even in June. So we are using a single line chart to show the trend over 6 months. So basically, line charts are ideal for trends over time. When you want to show a trend over time, it's better to use the line charts as you see here. And basically, how we are doing the line chart, we learned it so far. We are having the months, we are having the sales, then we are having the figure size, and we are plotting the line chart, and in this part we are labeling the x-axis, y-axis, and we are putting the title, and here we are showing the legend. The legend is being shown there, which is here, and also we are having the grid. As you see, we are having the grid, these grained lines. If you want to have that, we simply call the grid function and put true in parentheses. So here we learned that if we want to show something over time, like a trend over time, it's ideal to use a line chart. However, on the other hand, if we want to have the discussion over the correlation, we see that it's better to have a scatter plot, because now here we can see the overlaps quite easily. It's very much traceable. We see that, okay, this part we are having the density, but this part it's empty, completely empty. So it's good to use a scatter plot when we are dealing with correlations. For example, here we are having the correlation between the height of people and their weight. Here we are generating our height and weight. For example, we are having the normal distribution being used for the height, and we are having again a normal distribution with the standard deviation of 5 and the mean of 0, and we are generating 100 points with respect to this information. And also here we are having the mean of 170 with the standard deviation of 10, and we are having 100 points or heights being generated. We are having the size, and we are plotting our scatter plot, height, weight, color, alpha, which is the transparency, and the label. And we are showing the grid as well here. So we use the grid function and we set it to be true. We see that here, for example, when we are having the height of 170, the majority part for the weight is between 80 and 90, and we are having a lot of overlaps here. However, for people that are usually, for example, having the height of 190, in our sample, we don't have any of them being lower than 90 kilograms of weight. Okay, at least they are 91 or 92 based on this sample. So in our sample here, we see that usually the higher the height, the higher the weight. So it can be concluded from only this sample, but we need to test further samples as well to have an overall conclusion. But this is just a sample, and I'm trying to give you some insight of how we can interpret and understand this scatter plot. After that, we are going to review the bar charts. Bar charts are very good for comparison. So if you have, for example, category comparison here, it's better to use a bar chart. We're having product A sale, product B sale. So on the x-axis, we are having different types of products. On the sale axis, we are having the number of sales. And we see that product D sold 600 copies, let's say, which is larger than the other ones. So we see that it's very easy to plot this using a bar chart. And here, as always, because we are dealing with bar charts, we are having the products, we are having their sale, we are having the size of the figure, and we are using the bar function in order to plot our figure. We are customizing the color as well. We are having the edge color to be black. And here we see that we are having the grid only for the y-axis. So this part is only having the grid and not this part. Okay. So this is how we can get some insights from our information and our raw data. When we are having some data and we want to interpret this data, it's very good to have some figures so we can understand something from the figures. It's much easier to understand things from the figure. This is why initially we decided to, plot a bar chart, a pie chart, etc. But it's also very important to know which figure we need to have a good understanding. So if we are having the sale of our products in our bar chart, we can see it's very good. But we can also have it in a scatter plot. But a scatter plot like 1 point here, 1 point here, 1 point here, and 1 point here. It's not that we cannot understand anything from that, but it's ideal to have it in a bar chart so we can have a better visual plot that says everything in one glance. Okay, so this is why we need to use bar charts here. For example, when we are having different category comparison. Category means product A, B, C, and D. And here we would like to have a figure like this. So this is the best one that we can have. We are combining different concepts. We are having bar charts and also a line chart. So the line chart is showing us the line plot, is showing us the profit, and the scale is on right, you see. Okay, it is shown with red. And for the bar chart, the scale is on left. So here, for example, in the month of January, the sale was around 500 and the profit was around 50. Okay, the profit, which is the red one, which was 50, but the sale in January was around 500. However, in the month of March, we had the sale around 800, but the profit was around 100. Okay, so we see that when we compare these 2 points, we see that in the month of January, we had only like the profit of $50, let's say. Now we are having the profit of $100. So basically our profit somehow doubled. Okay, our profit somehow doubled from January to March. But how much the sale has changed? So the sale is 500 and here it's 800. So for the increase of 300 of sales, we could double our profit. This is one insight that we can understand from comparing the January and March. And of course, we can compare January and February, January and March, January and all the months, then February and March, February and April, February and May, etc. until the end. So we are having a comparison over all the months, and then we can have an average saying that, okay, by the increase of this sale, this unit in sale, we can have the increase this much in percentage of profit. Okay, this is one insight that could be interesting for people from the Department of Marketing or Sales. And they can see, okay, if we increase the sale this much, we are going to get this much of profit. Now let's see how we can increase the sale. For example, here we see that the sale in the month of January was around 500. And here in the month of June, it's around 900. So it's nearly doubled the sale. If this increase is at the same time happening as we are having some promotions, some sales, or we are having some advertisement, it shows that our advertisement is working. You see, because we are increasing the sale and also increasing the profit. So this can be an evidence saying that, okay, we are doing some promotion and it works because we has increased the sale and the profit. So let's invest more in this way. So this is some insight that we can get from this figure. And it's very important to have the right figure so you can have the correct insight easily taken from the figure. Okay. And if I want to draw this, we simply import the necessary libraries. After that, we are having the size here, the size of the figure, and then we are having the cells, the months, and for the bar chart, I'm having it here, the function for the bar chart, month, cell, color, label, and alpha, the transparency level, and the labels, okay? And here, we are saying that first for the first chart, which is our bar chart, we are using the AX1 to let the compiler know, okay, we are having two AXs and this is my AX1. And here when we were discussing the sizes, we were using the AX1 because we were discussing the subplots, okay? And here also we are saying that, okay, for the label Y, we need to have the color blue. This is why we are having the color blue here on the label. And then we would like to create our second y-axis. Second y-axis is for the profit. Okay. Here we are having the profit. So these are the units that are used for profit from 50 to 130, 50 to 130. We are having the plot, months, profit, and marker, color, label, and we want it to be dashed line. So we see that it's not a solid line, it's a dashed line. Then we are having the Y label. We would like it to be red. We choose it to be red. So here is our red. And then the label of the Y-axis is also profit. It's also red. It is also red. And here we choose the title. We choose the place of the legend. Also, we include the legend. We want it to be upper left. So on the left side, upper, we're going to display this. And we're going to use the show function to display this. So this was a very good example of how we can have the right plot and how to interpret this information. Finally, we are having a comparison here between the line chart, scatter plot, and the bar charts. And for the line chart, it's best for the trend over time. For the scatter plot, relationship between two variables, for example, the correlation. And when we are having the comparison between different categories, it's good to use bar charts. An example of the use cases of line chart is, for example, the stock price or the temperature changes. For the scatter plot, whenever we are having two variables like sales and marketing spend, height and weight. And for the bar chart, we can have sales by product or votes by candidates. For the scatter plot, when we are having sales by marketing, we can understand that with the increase of marketing, is the sale increasing or not? It's very important to understand that for many departments in a company to see if their strategy is working or not. So if it's not working, they're going to change it. So for the line chart, they show the pattern and trend, but they're not suitable for discrete categories. For the scatter plot, they identify the correlations and outliers, and it's hard to interpret them with dense data. And for the bar chart, they are very easy to compare, but the thing is that they cannot show the trend over time. So depending on what we are looking for, we need to choose smartly which one we need to have for our data. Thank you for watching. Welcome back. In today's video, we would like to talk about box plots. They are also known as box and whisper plots. Here is an example of our box plot here. And now we are going to discuss different parts of a box plot before we can go further and discuss the details of how to plot them. In order to know what box plot is, we need to mention that they are powerful data visualization tools that show the distribution, spread, and outliers of numerical data. For example, they summarize the key statistics such as the minimum here and the third quartile, and the maximum here. Okay, and a box plot consists of boxes that represent the interquartile range. So here is the interquartile range, for example, and 50% of our data exists there. Okay, and then we are having the median, which means that this point is the middle point of our data. We call it Q2 as well. So it means that 50% of our data is below this median and 50% of our data is above this median. Okay. Then we are having the lower whisker, and upper whisker. We also know them as mean and max. But how can we calculate the lower whisker and upper whisker? In order to calculate them, there is a formula. We are going to have the Q1 here, first quartile, and second quartile, and the third quartile, okay, in a box plot. So the first quartile is here, and this is the third quartile. Here, when we are having the difference of the Q3 and Q1, which is here, okay, we are going to calculate the interquartile range. When we are having Q3 minus Q1, we are having the interquartile range. Okay, this is the number that we want. And in order to calculate the lower whisker and the upper whisker, we need this number because the formula for lower whisker and upper whisker is the following. So Q1, okay, Q1 minus 1.5 multiplied by IQR, or interquartile range. So this number is calculated based on Q3 minus Q1, and it is multiplied by 1.5. And from that, we are reducing the Q1, which is this number, okay, first quartile. And then this is the output of this formula will decide the lower whisker, okay, excluding outliers. We're going to discuss outliers as well. And when we are having this formula, we are going to calculate the upper whisker, meaning that we are going to have Q3, which is here, plus 1.5 multiplied by interquartile range. The output will give us the value of the upper whisker. This way, we are calculating the lower whisker and upper whisker. Okay? So now let me review. So we are having the Q1 first quartile. This means that 25% of our data is below this Q1. Q2, which is the median, means that the 50% of the data is below and 50% is upper. Q3 means that third quartile, which is our third quartile, means that 75% of the data is below this Q3. Okay, 75% is below, and the remaining 25% is above this. And this is how we can have the Q1, Q2, and Q3. We also discussed the interquartile range, which is Q3 minus Q1. It's going to give us this part. And finally, let's talk about outliers. So an outlier is a data point that is unusually far from the data set, okay? Based on the, for example, 1.5 multiplied by interquartile range, okay? So this rule gives us the upper whisker, and the lower whisker. Anything that, and we are having the lower whisker here and upper whisker here. So anything that falls below the lower whisker is our outlier. And anything that is above this upper whisker is again our outlier. So anything that is unusually far from the dataset. This way we are going to understand the outliers. So it was a good introduction to box plots. Now we are going to continue in the following videos having some coding exercises of how we can plot box plots and deal with different parts of this. To review, we are having the Q1, which has the 25% of the data is below it. Q2, 50% is below it. Q3, 70% is below it. Then, based on Q3 minus Q1, we calculate the interquartile range, and we use that to calculate lower whisker and upper whisker. Anything that is lower than our lower whisker or above our upper whisker is our outlier. In the following videos, we are going to dive deeper into box plots. Thank you for watching. Welcome back. In today's video, we are going to learn how to plot a box plot. Here we are importing the necessary libraries. We are putting the seed for reproducibility, and then we are having 100 random values being generated using the normal distribution. And this seed will help us whenever we rerun the code, we see the same data. If I comment this part, it means that we are going to have new data being generated after each run. So you see it changes. See? Okay, let's keep with this box plot. Okay, now we are having here the size, and simply we use the box plot function and put data to plot our figure. Here we are having the label, basic box plot. Here is my label. Here is the font size, which is 14 and it's bold. Then we are having the label here for the y-axis, which is value. Okay. Now we want to display the plot, so we use the show function. Now, what does this plot mean? Understanding this plot is very important because it's not only about plotting it, but also understanding it and provide some explanation and discussion over this. Now, based on our introduction to boxplot, this line is the Q1, okay? This above line, the end of the box is the Q3. This orange line is Q2, which is our median. It's very important to know that it's median and it's not the average. Okay, it's median. It means that 50% of the data is below that and 50% of the data is above that. Necessarily, it should not be in the middle. Okay, it's a median. So it's the middle number in our data set. It can be, for example, 50 when we are generating 100, for example, number. We are having 49 numbers below this from, for example, from numbers, if we label them from 1 to 49, it's below this. And we are having from 51 to 100 above this, and this is the fifth number, and it shouldn't be necessarily in the middle. Okay, so it's a median. It's important to know this concept. So this is the Q1, this is the Q2, this is the Q3, this is my lower whisker, and this is my upper whisker. Okay, and these two that you see, these two empty dots, let's say, or let's say circle, these are outliers that are unusually out of the range, and they are unusually far from our data set. So if I run the code one more time, this time we see that we have no outliers. We are having the Q1 here, Q2 here, Q3 here, the Q2 is here, and the interquartile range is Q3 minus Q1. So all the things that are in this box is my interquartile range. It means that 50% of my data is distributed in this box. Okay, so this is also another point to consider. So if I increase my data to 1000, so we see that now we are having more outliers in the lower than the lower, below the lower whisker and above the upper whisker, and we are having our Q1, Q2, and Q3 here. So I think this was a very good example of not only to learn how to plot a box plot, but also how to understand it and explain it and describe it. Thank you for watching. Welcome back. In today's video, we are going to learn about having some little customization for our box plots. We learned that we can have it in black and white, but what if we want to make it visually more beautiful? We can add colors. Let's learn how we can do that. We are generating numbers here. We are having the size of the figure, and we are having the box plot. We are having the data. The patch artist function is going to help us. It is assigned to true, and it is going to help us to fill the box plot with color. So it allows us to fill the box plot with the color. And then this box props is going to actually fill the box with the color light blue. So this is how we can have a box plot that is colored. Also, another concept that we can have here is about the notch. So in order to have the notch, simply we can have notch equals true. So when I have it here, you see that we are having now the notches here, and it is going to give us some information about our data. So when we are having the narrower notch, it means that we are having higher confidence in the median, and when we are having it wider, it means that we are having more variability in our data. So it's very important to have it if you want to do some measurement and statistical tests and assumptions, and you want to check some information there. Notch can help you to have it there. So this, in order to be included, is simply we write down then the keyword notch, and then it equals true, and it indicates the confidence interval around the median, because we see that the median is the orange line and the notch is around that. Thank you for watching. Welcome back. In today's video, we are going to learn how to have multiple box plots in one figure. Here we are having group 1, group 2, and group 3. So we are having 3 data sets, and we are plotting the box plots for each one of them, and finally we can have a comparison between them to analyze our data sets. Okay. When we come here, we are generating 100 numbers with the mean of 0 and the standard deviation of 1 for data 1. We are having it for the mean of 2 and the standard deviation of 1 for the data set 2. And for the data set 3, we are having the mean of -2 with the standard deviation of 2 here. Okay, so now we are having our data, everything is ready. We are having the size of our figure also. Then we are having the box plot to plot our figure. Here we are having 3 data sets and we want to have all of them. So we're going to include the data 1, data 2, and data 3, comma. Then we are having the labels like group 1, group 2, and group 3, which are shown here. Group 1, group 2, and group 3. Here we are having the title, the box plot for multiple group, font size, and the bold, and the label for the y-axis, which is values. Okay, so when we run the code, we see this box plot, for example. Now, this one, you see that has more variation. Why? Because the standard deviation of the third data set is larger than the others. The others were having the standard deviation of 1, but this one has a standard deviation of 2. So we understand that the variability in this dataset is larger as compared to the dataset 1 and dataset 2. And we understand that the interquartile range is bigger as compared to Q2 and Q1. So we are having the 50% of our data here, while here the data is more dense and also it's more dense as compared to group 3. So these are the things that we can understand. And also we see that the lower whisker and upper whisker are much far away from the Q1, Q2, and Q3 as compared to here. So we are having the lower whisker very close to the, for example, Q1, but here the difference is larger. And these are the things that we can understand rapidly when we are looking at the figure. But then we can also have the notch to be true. So when we look at the figure now, we see that, for example, in this place, it's very wide, the notch, but this place, it's very narrow. And also, it is something between this one and this one. For the group 1, it's something between this one and this one. So here is narrow. It means that we can have more confidence, sorry. And here it's very wide. It means that we are having more variability in our data set. This is also another thing that we can understand. Also, as a reminder, we can see that our outliers here that are below the lower whisker are here, and we are having one that is above the upper whisker. And here is my median, here is Q1, and here is Q3. In this video, we learned how to have multiple box plots in one figure, and also we understand that we can explain them, and we learned how to interpret different box plots and compare them with each other. Thank you for watching.
Welcome back. In today's video, we are going to learn how to have our box plot with mean marker, as you see here. Okay. We are having our 3 data sets. We are having the size of the figure, and we are having the box plot here. This is my box plot. We are having data 1 to 3 there. We are having the labels from group 1 to 3. In order to have the mean marker, we need to have this keyword. Show means equals true. So it is going to show it. And its properties, when we want to discuss, we need to have the marker with the D style. We can have X, we can have O. It depends on what we are looking for. For example, O we can have when I run. You see now it's O, you see, okay. And it's of orange color. So we choose the color and we choose the edge color as well. So the edge color, you see it's black and itself it's orange. We can decide whatever we want. So we can have X, for example, as the marker. So when I run, you see now it's X. So I would go with O because I think it's nicer. Yeah, okay. So now we are having the mean marker. This is how we can include them. We have the keyword show means equals true. Then about its property, we're going to include, for example, the edge color, the marker color, and the style of the marker. This is about the marker. What about if we want to have another way of plotting our box plot? If we want to change it, we can have the, for example, here equal to false. Okay, so when I run the code, sorry, I need to have another comma here. Okay, so when I run the code now, we see here we are changing the way that we were plotting. We are now plotting our box plot here in this photo horizontally and not vertically anymore. So we put the vertical to be equal to false, so it is going to have the horizontally. So if I put the vertical to true, it is going to keep it as it was. And if we want to have it in a horizontal way, we need to keep it equal to false. So now it's horizontal. So if you think that it's better, it's nicer, or if you are more comfortable with this way, you can show it this way. This is group 1, this is group 2, and this is group 3. And here is the lower whisker Q1, Q2, and Q3, and upper whisker. And this is one outlier, for example, and etc. until the end. So this is how we can have not only a horizontal box plot, but also we can show our mean marker in box plots. Thank you for watching.
Welcome back. In today's video, we're going to talk about heat map. But what is a heat map? A heat map represents numerical values using colors, as you see the example here. In this example, we are presenting our data using colors. And lighter colors represent low values. For example, we can see a light color here and here. So they represent low values, while darker colors represent high values. For example, we can have a high value here and high value here, for example. And heat maps are usually useful when we are discussing the correlation. In order to understand the correlation, we can use heat map. They can give us very valuable information. For example, the parts that we see darker colors is exactly the parts that we are having more correlation. And it can help us in machine learning, and it will be useful in visualizing geographical or temperature data as well. And also they are very good for comparing categories, different categories over time. So in the following videos, we're going to talk about heat map and how we are going to learn how we can plot them using Matplotlib library. Thank you for watching. Welcome back. In today's video, we're going to learn how to plot a heat map. You see, this is our example. Here, in order to plot a heat map, we are first of all importing the necessary libraries. We are putting the seed in order to know that when we are generating random numbers, when I run the code one more time, I will see the same result. Okay, I will get the same result. But if I comment the seed part, and I compile, you see that this time the result is different. When I run one more time, we see that now the result is also different. Again, the result is different until here. So I think it would be a good idea to have our seed activated. So whenever we run, we see the same results. Okay, so this is putting the seed for generating random numbers, and this 42 is an arbitrary number. We can choose another number. We can choose 50, for example. Then here we need to have our data. Our data shows that we are going to generate randomly a 5 by 5 matrix, that the numbers and that the values for this matrix is ranged between 0 and 1. So we are going to generate a 5 by 5 matrix, and each number is going to take between 0 and 1, and this matrix is assigned to data. Here we are setting the size for our figure. Then here we are using this function imShow. This function is used to plot our heat map. Now here we are using the matrix that we generated. We're using the color map cooled warm, so the color is going to have this scale for the cool warm. This is what we are using. Then we are having interpolation. So interpolation controls how pixels values are interpolated. You see, for example, here they are very sharp. So one pixel is totally separated from another because we are using the nearest type. Okay, so interpolation controls how pixel values are interpolated between grid points. And because we are using the nearest, it means that we are having no smoothing between any two cells. And you see the edges are sharp. Okay, so they're distinguishable. There are different things that we can use here. For example, instead of nearest, we could have bilinear. So it has a smoother transaction. You see, it's changing. We can have even more smoother transaction by having bicubic. So when I run the code, we see that it's even smoother. And also we could have a very smooth transaction for spline 16. So when I run, okay, so this is another way. So depending on what we are looking for, we can choose also the type of interpolation. I would keep on with the nearest for the moment because it's very good to distinguish one cell from another. Now that we are plotting our box plot, here we are labeling the title. We are having the basic heat map. The font size is 14 and the font weight is bold, so it's bold. Then we are having the color bar, sorry. This is my color bar. And finally, we are using the show a function to display our plot. So in this video, we learned how to generate a matrix. For example, a 5 by 5 matrix randomly is generated between 0 and 1 and it is assigned to data. Also, we learned how we can plot a heat map using the imShow function, and then we use the data. We are choosing the color map. We chose cool warm, and then we learned about interpolation, and also we learned that different types of that could be used. For example, nearest, bilinear, bicubic, and spline 16. Thank you for watching. Welcome back. In today's video, we are going to discuss how we can draw a correlation matrix heat map. Here is my heat map, and it's a correlation matrix heat map. We see that we are having the A, B, C, D, and E as the column label. Each column has its own label. So this is column A, this one is column B, column C, column D, and column E. And here we are having row A, row B, row C, row D, and row E. We would like to know the correlation between A and B, for example. For example, product A and product B, or the column the data A and the data B. So correlation is very important. So we see that for A and B, the correlation is negative. Okay, 0.14, negative 0.14. And then, for example, if we want to check something that is huge, the correlation is large. For example, we can see the correlation between E and B, and this is 0.69. So the correlation is very large, and we can say that the changes in E and B, for example, any changes that is happening in E can have impact on B, for example, because the correlation is huge. Okay. And also we can see, for example, between D and C, we are having a large coloration. Then, for example, we see that here we are having a not a very large correlation here between D and E. The correlation is 0.18, and for example D and E here they have no correlation, so they have no impact on each other. But what these numbers mean? First of all, when we are discussing about correlation, when it is plus 1, so when the correlation is 1, it means that we are having positive correlation. So both variables increase together. So when one variable increases, the other one also increases. And this part we don't consider the red part because A of course has impact on A. So this part is negligible. And for the B and B, C and C, etc., we want to know the correlation between variables. Okay. So B and E, they are having a correlation of 0.69, meaning that the increase in B has impact on increase in E. So they both increase together. Okay. So when we are having -1 negative correlation, it means that when one increases, the other decreases. For example, when we check E and A, we see that the number is -0.09. So it means that an increase in E will lead to decrease in A. Okay, or another negative number, an increase in C will result in decrease in E. Okay, and this is the number of correlation. So this impact is larger than this impact because it's much closer to number -1. Then when we are having the correlation of 0, it means that we are having no correlation. So any changes in D has no impact on E. It's a very good way to understand uh, the impact of different variables. For example, an example could be during the COVID-19 pandemic, we could have the correlation between the uh, number of hospitalized people and number of death. So the increase in the number of hospitalized had a large correlation with the number of death. So this is one thing that we need to consider. So correlation is very important, but how we can have a correlation matrix heat map? Here, first of all, we are putting the seed in order to rerun the code to get the same result. Then we are having a matrix of 10 by 5. So we are having 5 column A, B, C, D, and E. And we are having 10 rows, 1, 2, 3, 4, 5, etc. Let me show you the table. So when I run the code now, I see here. So this is column A, column B, column C, D, and E. And these are different rows, 0, 1, 2, 3, etc. until the end. So we are having a matrix of 10 by 5, and this is our data. Okay, so this is our data that is being randomly generated between 0 and 1, and we are having 10 rows and 5 columns. Okay, and this matrix is assigned to df. Here we are calculating the correlation of this matrix. For example, when we were showing this matrix, let me show you again. We are having the first column to be 0.5 and negative 0.14 for A and B respectively. We see that the reduction in A, for example, is having the increase in B, for example. Then further reduction in A is having reduction in B. So we are going to have the correlation measurement one by one for each element to have an overall understanding of how changes in A can impact anything or any changes in B. And also for B and C, B and D, B and E, A and B, A and C, A and D, A and E, etc. So until the end, we are going to compute all the correlation and have an average over the correlation on the output. Okay, so this is the output that we want to get in the end. So we generated our matrix and we assign it to df. Here we are calculating the correlation. So df dot CORR, it is going to it's a correlation measurement that it is going to measure the relationship between two variables. And we said that if we are having, for example, +1, it means that it's a positive correlation. We are going to have negative correlation for -1, and 0 means no correlation. And the method by which we are doing the correlation here, usually we are using the Pearson correlation, which ranges between between -1, sorry, and 1. Okay, this is the figure size that we are having here. And now it's the time to plot our heat map. So I use the Seaborn library, and then I have the heat map function. I write down the correlation matrix name because here we calculated the correlation matrix and we are assigning it to core underscore matrix, and we are having it to be shown. We are having the anode equals true, meaning that we are going to have these numbers. So if I remove this part, you will see that we don't have these numbers on the cells. Okay, you see that we have no numbers, so we still can understand. For example, negative 0.2 is this number, so this is having a negative correlation, these two, and the ones that are like this are having more correlation because they are somewhere between 0.6 and 0.8. But in order to understand it better, it's easier to have the numbers on the cells, let's say. So we are going to use the anode equals true to have the numbers on the cell. So it's very easy to understand the correlation rather than trying to understand the color scale. We are choosing the color map here. We choose cool warm. We are mentioning that all the numbers that are shown here, show them with 2 decimals. So .2f means 2 decimals. We are having 1, 0.00, 1.00, 0.47, etc. So everything is shown there. Also, this is the line width. For example, now I choose it to be 0.5, but if I increase this number, for example, 2.5, you see that we are having a larger edges width here. So it depends on what we are looking for. We can customize this one as well. You see it's now smaller. And here finally is the title of our heat map. We are saying that correlation matrix heat map. We are having this font size and we are having it being bold. And we are displaying our plot here. So in this video, we learned how we can generate a table or let's say a matrix with different columns, 5 columns and different numbers. And then we measure the correlation between any two variables. Using the core function, we assign it to a new core matrix variable, and then this is shown, which is our table here. Okay, it shows, for example, any changes in A, how it's going to impact on B, or on C or D, and any other variables. For example, B, when it is increasing, C, it is going to decrease. Also, A it is going to decrease, and also D is going to decrease, but E is going to increase, for example. This is what we learned in this video, and also we learned how to plot a correlation matrix in Python. Thank you for watching.
Welcome back. In today's video, we're going to talk about heat map with custom labels. So here you see my labels are morning, afternoon, evening, night, and late night. And here I'm having the days of the week. So Monday, Tuesday, Wednesday, Thursday, and Friday. And based on my data, I created this customized labels for my heat map. But we want to learn how we did that. First of all, I'm having the size of the figure. Then I'm having the days. So I'm including Monday, Tuesday, Wednesday, Thursday, and Friday. So 5 days are included, and I'm having 5 times. You see, morning, afternoon, evening, night, and late night. After that, we would like to create a 5 by 5 matrix with random numbers between 1 and 99. So the starting point is 1, but the ending point is 99 because 100 is exclusive. Okay. So, and we are going to generate randomly integer numbers between 1 and 99, therefore, to create a 5 by 5 matrix. Then, now that we created everything, we assign the numbers to the data. So our matrix is in data. I use the heat map keyword, let's say function, and then I plot the heat map with my data. That is a 5 by 5 matrix. Then I'm having the anode equals true, meaning that these numbers are showing on each cell. So when I remove this part and I run, you see that you will see no number on each cell. But when I have anode equals true, we see that the numbers are there also. So we are having the anode for having the numbers on each cell. Then I'm having the color map, so I choose this color. This is my scale, and it's a very nice color, in fact. You can store the code if you are interested. Then we are having the labels of the X here, X axis. The labels, in order to have them, we are assigning times to them. So times is my morning until the late night label. So morning until late night, they're on X axis. In order to assign that, we need to have the keyword X tick labels, and we assign times to it. Then we are assigning days to Y tick labels. So we are having the y-axis with the days label, starting from Monday, Tuesday, Wednesday until Friday. And finally, we are having the line width 0.5. We can have a thicker line width. For example, when I do it, you see that it's thicker. If I have, for example, 5.5, you will see that it's much thicker, but it's something that you can customize. So you can choose what you want. We can, for example, by default consider 0.5 because I think it's nice enough. And finally, we are having the heat map with custom labels. This is the title. You see here the font is 14, the font size, and then we are having it shown in bold. So in this video, we learned how we can have customized x-axis and y-axis labels. Thank you for watching. Welcome back. In today's video, we are going to talk about normalized data heatmap. Let me first of all reduce the size of the figure. I want a figure 4 by 3, so it's smaller now. We can discuss it better. So now you see that all the annotation on the cells, so all the text on the cells, the numbers, they are normalized. So they are between 0 and 1. This is the scale. How we can have a normalized data heat map. First, we are having the size. Then again, I'm generating a table of 5 by 5, or let's say a matrix between 1 and 99 because the ending point is exclusive. We are having days and times here to work with the data. Then we would like to normalize the generated data. Okay. In order to do that, we are having the formula. This is a famous formula. We are having the data minus the, let's say, the minimum. So the current value minus the minimum value of the data set. And all of this is divided by the maximum number in our data set minus the minimum number. Okay. Using this formula, we can normalize all the elements. So for example, if this number is 60, 60 minus the 60 will be the data minus the minimum of the data set divided by the maximum minus minimum. Then again, we do this, for example, this number minus minimum divided by the maximum minus minimum. Okay, but not exactly this number because this is already normalized. So the number that was here, for example, in this cell, we were having number 60, and in this cell, we were having number, for example, 26, let's say, just an example. Then this 60 is used as data in this formula. So 60 minus minimum divided by maximum of the data set minus minimum, it will be, just imagine that it will be 0.22. So this 0.22 is placed here. Then in order to obtain this 0.8, we are having the 26. For example, the original number was 26 before normalization. 26 minus the minimum of the data set divided by maximum minus minimum, it will be, for example, 0.8. And we do it for all the cells, and then we reach to a table which is normalized that we are having here. Okay, so we use we use this formula and the table that we generated here to have the normalized data. Then we use the heat map function. We want to have the heat map on our normalized data. We are having the annotation, so annote equals true because we want to see these numbers on each cell. We choose the color cool warm and the line width is 0.5, and then we are having the title. So in this video we learned how we can have a normalized data heat map. Thank you for watching. Welcome back. In today's video, we are going to learn how to have a correlation heat map in which the upper triangle is masked. You see, we only see the lower triangle and the upper triangle is masked. But how can we do that? We are having the size of the figure. We are having the seed being set here. So every time that I run, we are going to get the same result. The result is not going to change. Then we are generating a table of 5 columns and 10 rows. So 5 columns A, B, C, D, and E. Then 10 rows 1, 2, 3, 4, 5, etc. Then we are calculating the correlation between any two variables and assign it to my core matrix. Now, in order to have the mask on the upper triangle, we simply need to use this line of code. Okay, so we are having the trio function that is going to mask, or let's say hide, the upper triangle of the core matrix and return it to my mask. Okay, and then we are using that my mask, assign it to the keyword mask in the heat map. So let me say it one more time. Here we are using the trio function, and this is going to help us to hide the upper triangle of the core matrix. Okay, it is commonly used to display only the lower triangle in a heat map. And this is how we can do it. Basically, what you need to care about it in this line is this name and trio, and then the name of the matrix that you want to hide its upper triangle. And that's it. Then we are using the heat map function. We are mentioning that, okay, we want a heat map over the core matrix. We are discussing because we want to mask the upper triangle. We are going to use the keyword mask, and my mask is assigned to it, meaning that, okay, mask the upper triangle here for me. We are having the annote equals true because we want to have these numbers on the cell. Otherwise, if I don't have this line, if I remove it, you will see that no numbers will be displayed. Okay, then we are having the color scale, which is here, and finally we are having the width of the line. And here we are having the title saying that correlation heat map upper triangle masked, sorry. Then we are having the font size and the bold, and that's it. We use the show function to display our figure. And if in case you wanna hide the lower triangle and you wanna mask the lower triangle and have the upper triangle being shown, simply instead of having the trio, you will use the trill. Okay, So trill is going to help us to have this triangle. So trill or trio, okay? So it depends on you. This part is similar, so the tree part is similar. Then instead, when you're having the U, it means that you are masking the upper triangle. But when we are having, instead of that, we are having L, it means that we are hiding the lower triangle. Okay. And this is how we can simply use it and benefit from having a correlated heat map in which we are having either the upper triangle masked or the lower triangle masked. Thank you for watching. Welcome back. In today's video, we are going to learn how to plot a 3D or let's say three-dimensional scatter plot. Here is my figure. Here is my x-axis, here is my y-axis, and here is my z-axis. But how can we draw that? First of all, we are putting the seed there in order to make sure that every time that we run the code, we are going to see the same result and not a new generation will happen with every run. Then we are having the x, y, and z variables that are generating the coordinates. So this one is going to generate 50x coordinates. This one is going to generate 50y coordinates, and this one is going to generate 50z coordinates. Then we are having the size of my figure. Let me just reduce it a bit. So I think it's nicer to have it smaller. So, okay, now it's smaller. And then here we are telling the compiler I'm looking for a three-dimensional figure. Okay. Here I mentioned that I would like to have a three-dimensional figure. And this place I call the scatter function where I have my three variables x, y, and z. Then we are willing to have a cool warm color map. Okay, so this is different colors that you see here. So I need to have the C, which is my color, to equal to something. I could have it simply to red. So when we equal it to red, we see everything being red. So this color map is not used. This color map is only used when we are having unique values for each data point. In order to have a unique value for each data point, we can have, for example, we can equal it to the numbers that generated for the x, because in x, for example, we are having many numbers, 50 numbers that are randomly generated between 0 and 1. And it can be, for example, 0 0.11, 0 0.52, 0 0.70, etc. until the fifth element. Okay, the fifth element. Each of them are having one number. Each element is having one value. Okay, we can use these values and assign it here, and based on that we can generate our cool warm color using the color map. So when I run, you see that different colors are seen. So the colors that are you see that are less darker are the colors that are lower in this place. For example, they're having their y somewhere between 0.2 and x somewhere between 0.5. But the colors that are darker are somehow having the larger x and y values in the coordination. So we can also use that. We can also assign it to y, because also y, the same thing happens here. Also z. So when I have the y, you will see that the colors are different. And then I'm having the size 50 for my figure. I could have it to be 500, for example. It would be very big for each of the data point. They are much bigger. Now, I think 50 is a good number to have them here. We are having the transparency level 0.8. So it is going to also show us the overlaps. We can adjust it as we want. For example, we can have 0.5 here. You see. And finally, we are having the edge color black. So the edge color and the outer layer of each data point it's black. We could have it, for example, green. So when I run, you see that they are green now. You see the edge color, it's green. So we can change it as we want as well. And finally, we are labeling the X, Y, and Z axis and the title of the figure. In this video, we learned how we can have a three-dimensional scatter plot. Thank you for watching. Welcome back. In today's video, we're going to learn how to have a three-dimensional line plot. Here is my example. You see that here we are having a line plot that is three-dimensional. So in order to do that, we are having the line space being generated between 0 and 10. So we're generating our data for the variable t between 0 and 10, and we are having 100 points, okay? Then my first function is the sine of t, and my second function is the cosine of t. Then we are having the we are having the z-axis equal to t. So the z-axis represent the time progression, okay? So this is the x-axis, this is the y-axis, and this is the z-axis. It's a representation of time. Then we are going to plot our line plot. So I use the plot. X, Y, and Z are the variables that we want to include, X, Y, and Z. Then we are having color equal to blue, and we are having the line width equal to 2. And here we are telling the compiler saying that we are looking for a three-dimensional figure. And at the end, we are labeling the axis and the title of the figure. So when I run the code, you see that we are having a nice 3D line plots. But we are having 100 points that are being generated between 0 and 10. So it can help to have a smooth shape here. But instead of 100, if I have, for example, 10 numbers only, you see that the figure is not that smooth. It has the edges that is sharp, okay? But the more that you increase this number, the smoother the figure will become. So you see that it's now a bit smoother than if I have 40, for example. It's a bit smoother. There are some still sharp parts we see here and there. But with the 50, let me test. So with the 50, it's almost smooth, but we can have, for example, 100 to make sure that it's really smooth. So when I run, we see that it's really smooth and we don't have any sharp edges here. So in this video, we learned how we can create a three-dimensional line plot. Thank you for watching. Welcome back. In today's video, we're going to talk about time series plot. Now, how can we plot them? We have the date on the x-axis and we are having the values on the y-axis. Time series is very important plot because it can provide us insightful feedback and results from different departments. For example, if you're having the time series of our sales for the last month, we will see that, okay, over the last month, how much was the sale over the last season, over the last year. And also we can use the historical data using time series to predict the future with certain degree of errors, of course. But this is not the lesson of today. The lesson is how we can plot the time series, okay? First of all, we need to generate a time series. In order to generate that, we are using the date-time library. So we are using the date-time library to say, okay, the date of the today, and then the last 30 days because I would like to have the time delta, and when days equals I, for each I in the range of 30 because I'm looking for the last 30 days. Then we are going to generate 30 integer values, let's say numbers, between 50 and 150, representing the values corresponding to each day of the last 30 days. So 30 values for 30 days. Then we need to create our data frame. So we are creating the data frame. So the date is assigned to the date. The values that we generated here are assigned to value. And here we are looking for ensuring to make sure we are just trying to make sure that the dates that are generated are sorted, because in time series we are going to start from for example 30 days ago and continuously come to the current time. We don't want it to be not sorted. It must be sorted, okay? Otherwise it's very confusing. So in this line we are making sure that the values that we have are sorted. Then after that, we are having the size of the figure, which is 10 by 5. So we can increase it, we can reduce it, it's as we want. And finally, we would like to plot our time series. So when we want to plot, you see that it looks like a line plot. Actually, it is a line plot. So we use the plot function. We are having the date and values that we created here, the data frame. So the date and the value is shown here. So we are having the date on the x-axis, we are having the values on the y-axis, we are having the marker O. If you remember from the section where we discussed the line plots, we are having the marker O here, and we are having the line style solid. So we are having a solid, and we would like the color to be blue. We can change whatever we want. We can customize it, for example, to have a dashed line, or instead of the O, we can have X, for example. Okay, it depends on what we are looking for, but we can customize it as we want, as we learned so far. And finally, we are having the labels here being shown. So here is the label date, this one, and here is the label value on the y-axis, and here is the title of here is my title of the figure. And here we are trying to rotate 45% these labels on the x-axis so it's readable. Okay, it's easier to read instead of having them like vertically. It's now easier to understand them. So vertically we are rotating the x labels for the increase of readability. And finally we are having the grid equals to true because we are having these gray lines for us to better evaluate the numbers, and the points are corresponding to each value. So in this video, we learned how we can have a line plot, let's say a time series plot, and how we can have the dates of the current date and the last 30 days. For example, if you're looking for the last 3 months, you can have like the size of the 90 for the days and also for generating the value. So when I run, you see that I'm going to have 90 days here, and the time goes back to December 2024 and even before that. Because we are having this December 2022, the 1st of December is here, so we are going to have 15 days before that. So 15 days we are in November, and then up until here we are having so for the last 90 days we can, for example, trace the sale on each day. Thank you for watching.
Welcome back. In today's video, we are going to talk about time series with moving average. So here you see that the blue line, let me make the figure a bit smaller. So if I have it 8 by 4, okay, it's better. Now, in order to have our time series, we see that it is shown by blue. So the original data, it's a line plot. We see that it goes up and down for the past 30 days. So we are using for the date time of the past 30 days, and we are having for each day one value. So 30 values we are having. Then we are having the 7-day moving average. So 7-day moving average is like we're starting from here. And at this point, to calculate this point, we are getting the average of the past 7 days. Okay, and we are calculating the average and we are putting it here. Then here we are moving one day forward, and now again we are calculating the average from here up until the 7 past days, and we are putting it here. Then another part here, here again. So this average is based on the last 7 numbers. So 1, 2, 3, 4, 5, 6, and 7. So these 7 numbers are calculated and their average is this point in this red part. Okay, and here, because we want to calculate this red part, we need to calculate the last 7 number average. Okay, so this is the first one, second, third, fourth, fifth, sixth, and 7, and not this one. Okay, not this one, only this one. So, and then we from there we are having this average, and then to calculate the next average, okay, again we go back 7 days. So this is a 7-day moving average. This is how we can calculate it, in fact. So now, based on what we are looking for, we need to know and understand how we can have the 7-day moving average with the time series. In order to have that, first of all, like before, we are having the dates for the last 30 days. We are having the generation of values for the last 30 days between 50 and 150. Then we are creating our data frame. So the dates and the values, we are creating the data frame and we are sorting the date to make sure that it is sorted. And this is the size. And here we are calculating the 7-day moving average. In order to have that, we are calculating the average over the value. Yes, so we are using values and we are using the rolling function to calculate the average, the mean, and the window is 7 because we are looking for the past 7 days. If we wanted to have a window of the last 10 days, we could put the 10 here, and when I run the code, you see that it's starting from here, okay, and not from here. So again, in order to calculate the moving average, we are having the value because we want to create the average over the values. And using the rolling function, the window is 7 because we are looking for the 7 days before. And because we are looking for average, this is the function for the mean. After that, we need to plot 2 plots, okay? One for the time series and the other one for our moving average, okay? So one for the blue one and one for the red one. Now, in order to have that, first we use the plot function. We are having the first one being date and value, and the marker we put it to be O. Line style is solid and the label is original data. So we are having the blue one here, the original data. This is the label. We are using legend. It's a solid line and it is marked each data point with O. Then we are having this part here where we are having the date and the averages of the past 7 days that we calculated here, and we assign it here and we are using it here. We are saying that the line style, we want it to be solid. We want the line width to be 2 now. So it's bolder, it's thicker, let's say. And then the color to be red. And this is the label, 7-day moving average. We could have the marker if we want. For example, we could have the marker equals, for example, X. So now when I run, we see that we are having the X also there. And whenever I run, we see that a new data is generated because I'm not putting the we are not setting the seed. So every time we run, the data will not be newly generated. When we are having the function seed, whenever we run, we are going to see the same result. But when we don't have that, we are going to generate new data every time that we run. So now we learned how to have the plots. We are labeling the date and value, the date and value, X and Y axis. We are having the title. We are having the legend to show our labels. This is the legend. We are having the X labels, the X-axis labels to rotate 45 degrees because we want it to be more clear and increase the readability. And then we are having the grid. You see the grid, the gray lines there, so they are the grids, and we are having the grid because it's easier to have them when we are it's easier to read the plot when we are having them. Thank you for watching. Welcome back. In today's video, we are going to have a time series plot, and we are going to highlight the peak and fro. In order to do that, we are having the peak here and the fro here. What do we mean by fro? Fro simply in time series dictionary mean when we are referring to the minimum point. So this is my minimum point here, okay? And this is my maximum point here. And we would like to highlight them in our time series. Here we are again having the dates from today as of the last 30 days, and we are generating integer values for the last 30 days. So 30 days, 30 integer values. Each day has one integer value between 50 and 150. Then we are creating our data frame here. We are making sure that the dates are sorted. Then, because we want to have the max point and min point, the peak and the fro, we need to work with the value that we are having here. Okay, so we created our data frame here. This one is for the date, this one is for the value. So we are going to use that value to find its maximum number. Okay, and when we are having that, we are assigning it to max point. And then here, because we want to find the minimum in our data frame, or let's say data set, among these values that are assigned when creating the data frame to value, we are going to use the value and find its minimum. After that, we are assigning it to the variable called min point. Now we would like to have our time series plot. Here is my time series plot. It's a date and value, so it's date and value, you see. Then we are having the marker O, so we are having the marker O here. The line style is solid line, so it's also there, and we are having the labels called time series. So time series is shown here with the blue line plot. Then when we want to highlight the peak and fro, we simply use the scatter plot. We call the scatter function. We are having the max point of the date. We are going to find it. And then max point value. Why? Because it is going to have some value on the x-axis and some value on the y-axis. So the value on the x-axis, which represents the date, we are going to find it. And we are having the max value point representation on the y-axis, which is for my value. And then we would like to show the max point with the color red, and we are going to label it peak and with the size of 100. We could increase or reduce the size, so it depends on us. We can have it 100, we can have it 200. So if I want to have 200 and if I run the code, we see that it's bigger. Okay, so we choose to have 100 because we are having the color red. It's already distinguishable, so it's already distinguishable when it is red. And the label is peak. You see the red is in the legend, the label is peak. So this is how uh, we manage to have the peak. And now if we want to have the minimum, we are going to have the min point for the date and value as well. We want to color to have the green. Then we are going to label it fro. And we can say minimum as you want. And then here is the size. So basically in this video, we learned how to highlight the peak point using this line and how to highlight the through point using this line. But before that, we first of all learned what numbers they are. So we found the maximum here, we found the minimum point here. Then here we use the scatter plot to navigate the coordinates and put the highlight there. Okay. And then finally, we are having the labels for the X and Y axis and also for the figure, the legend, the rotation of the X axis, we are having it here. And finally, we are having the grid here in the gray lines. Thank you for watching.
Hi, welcome back. In today's video, we would like to have a coding exercise with line plots. So you see that there is a function y equals 2 multiplied by x, and we would like to draw this. So this is my x-axis, this is my y-axis here. In order to plot this line plot, first of all, we need to import the relevant library. So Matplotlib library is imported. Then we need to have the points. When we are having the points here, we are having x equals 0, 1, 2, 3, 4, and 5. Y equals 0, 2, 4, 6, 8, and 10. So my function was y equals 2 multiplied by x. And we see that we reflected this in our data points. So whenever we are having an x, whenever we are having an x, we see that the y is double that value. For example, here x is 1, the y is 2. X is 2, the y is 4. X is 3, the y is 6. X is 4, the y is 8. And x is 5, the y is 10. So now we have the required data. Now we can plot our line figure or line plot, let's say. We are having the x and y. We are having the marker O. You see at each data point, we are having the O here. And we are having the line style to be solid. So it is solid. We could have different line styles, but here we prefer to have it solid. We are having the color to be blue. And we are labeling also our figure, which is y equals 2x. So after that, we are labeling the x-axis. X-axis is shown here. We are having the y-axis, so y-axis is also here. And we are also having the title of the figure, which is line graph example. We are also showing the legend, which is this part because we labeled our plot, the first line plot. We labeled it here. And when we are including the legend function, we are going to have the legend here. And finally, in order to show and display the plot, we are using the show function. So after that, we see that our plot is simply plotted when we run the code. So this is how we can have y equals 2x here in Matplotlib library. Thank you for watching. Welcome back. In today's video, we would like to have another line plot. So in this video, we are going to have x-axis and y-axis, and we would like to plot this figure. So we need to have 5 points here in this figure, and for each point, we are having one x coordinate and one y coordinate to have this point. Then another x and y coordinates for this point, etc. In order to do that, we are having the x values 10, 20, 30, 40, and 50. Then we are having the y values 15, 25, 20, 45, and 17. And using these two values, these two, let's say, variables that we are having here, x values and y values, we would like to plot our figure, our line plot. So first of all, we are having the x values, y values. We choose the marker to be O. We see that it's O. We choose the line style to be solid, we choose the color to be G, which is green, and also we are having a label called given data. So it is the legend here. Then we are labeling the x-axis, the y-axis, and also the title. So when we run the code, we see the figure. But there is some customization that we can do. For example, we could have star here instead of the O. Here we see that we are going to have stars, as you see. Or we could have, for example, X here. So it's X there, as you see it there. And for the line style, we could have dashed line style instead of having it solid. You see? And also for the color, we could have red, for example. We could customize it to red. We could customize it to whatever we want, depending on what we're looking for. So in this video, we reviewed how we can have a simple line plot. Thank you for watching. Welcome to this video. In today's video, we're going to talk about line plots. Here in my x-axis, we are having different dates, and on the y-axis, we are having some prices. And we would like to plot a line plot in which we discuss different prices for different dates. In order to do that, first of all, we need to import the required libraries. Then we are creating a dictionary. And as we know, when we are having a dictionary in Python, we need to have the key value pair. Here, the date is my key and the close price is my value. So for this key, I have its corresponding value. And for this key, I have its corresponding value. For this key, I have its corresponding value, etc. until the end. So we are having 1, 2, 3, 4, and 5. So 5 keys and 5 corresponding values are available here. And we see that in the data dictionary, we are having therefore the date and the close price. After that, when we created this dictionary, we're going to convert this data dictionary into a data frame using the Pandas library. Why do we need to do that? It's simply because it allows easier operations and data transformation. So this is why we use the data frame. And then also because we are having the date here in our dictionary, they are stored as strings, like text files. This is why we need to convert them. So in order to convert the text, this date column into a data time format, we need to use this line of code. So here, when we are, let's review it again. When we are having the dates in a dictionary, it will remain as a string, like in the text format. And when we are using the Matplotlib library, we require date-time format in order to plot the proper date-based axis. For this reason, we use this to_datetime function to convert our date from a string date into a actual datetime object. Okay, so here we are doing this as well. Then we are simply having the size of our plot, and we are using the plot function to plot our line plot. We are having the date and the closing price. We are having the marker O. We can of course change it. We have the line style, it's solid. We have the color blue and the label, which is close price. Okay. Then we see the label legend also here. This is why we are having a label and then we use the legend to show it. We are having the x-axis label. We are having the y-axis label. We are having the title of this figure. And then in order to have a better readability, we are rotating the x-axis labels by 45% using this line. We are having the grid. As you see, we are having the gray lines that is my grid. We use the legend function to have this label here, and we use the show function to plot our figure and display it here in the output. So based on this code, we first of all learned how to have our data in a dictionary where we have the key value pair and how to convert our dictionary into a data frame. And also, because we are using a date in a dictionary, it's a string and we need a date time based format for plotting. We learned how to convert that as well. Thank you for watching. Welcome back. In today's video, we are going to learn how to have multiple lines in a line plot. So here I have 3 lines here. So this is a multiple line plot, and all of them are in one figure. So line 1 is shown in blue, line 2 is shown in red, and also line 3 is shown in green. And you see that there are 3 different markers that are used. For example, here we are having the O, we are having the S, which is a square, and the triangle here we are having it. So, and this is my plot. This is the dashed line, the red one. And this one is the blue one is a solid line, and the green one is the dashed dot line. So how can we do that? How can we plot that? First, we need the Matplotlib library to be imported. Then we are having the x values. So 1, 2, 3, 4, 5. So the x-axis is the same for all of them, but the y-axis is different. Okay. So we see that all of them are having the same x values. So this in this place x equals 1, then 2, then 3, then 4, and then 5 for all of the lines. So x is shared. Then we are having the y values for different lines. We are having line 1, line 2, and line 3. Here we are creating the y values. Then here we are plotting multiple lines with labels. So we are having the x value for all of them, then y1, y2, and y3. We are having different markers, O, S, and the triangle you see. We are having different line style. So we are having solid line, dashed dot line. We are having different colors, blue, red, and green, and different labels as well. Then we label the x-axis label, and y-axis label, and the title, multiple line plot example. Then we are having the grid, we are having the legend, which is shown here. And finally, we use the show function to plot our figure. So this is how we can have multiple lines in one line plot. Thank you for watching. Welcome back. In today's video, we're going to have multiple lines with different width. So we see that we're having multiple lines being plotted here in our line plot. And we see that the colors are different and the width are different. We're going to review how we can do that. So for customization here, we're having the common x values for all lines. Then we are having different y values for different lines. For example, this one is for line 1, line 2, and line 3. Then we are having the plotting function. So we are using the plot function to plot our 3 lines. So here we are plotting our lines. We are having the x values, which is common among all of them. We are having different y values. Okay. Then we are having the markers that are different, O, S, and triangle. Then we are having different line style, and we see it here. This one, for example, is solid blue, dashed red, and dashed dotted green. So we see that they are also different. Then we are having the line width. One of them, so the blue one is having the width 2, the red one having the width 3, and the green one having the width 4. So blue, red, and green, different line width as well. Then finally we are labeling them here. After that, we are having the x-axis label, y-axis label, and also the title of the plot, which is here, multiple lines with different width and colors. And for better visualization, we simply use the grid function. We are having the gray lines here. We are using the legend function to have our legend here. And to display our plot, we use the show function. Thank you for watching. Welcome back. In today's video, we are going to plot a line plot, and we are going to discuss a new limit for our axis. So here is my x values and here is my y values, you see here. And then we right away start plotting our figure. So we are having x values and y values, we are having the marker, and we are having the line style, it's solid, the color blue, and the label. Here is the label for x-axis, for the y-axis, and also the title. We are having the grid here, which is true, so we are having the gray lines. We are having the legend here, and we are displaying our figure using the show function. So this is my figure. Now, how can I have the axis limits? In order to have that, we need to simply use the x-lim and y-lim functions and give new values to our axis. Okay, so for example, the x values are starting, it's starting from the 1 and it goes up until 5. So I want to have the axis limits for my x-axis from 0 to 6. Now it's from 1 to 5, but I want it to be from 0 to 6. And also for y-axis, we are having values from 10 to 30. So I would like to have values between 5 and 35. So you see it's from 10 to 30. I would like to have from 5 to 35, and here I would like to have from 0 to 6. So now that I have these two lines and I run the code, first of all, we see that the figure is much nicer, I think. Then we see that we are having the x-axis up until 6. We are having the y-axis up until 35. So this is how actually we can have new axis limits while we are plotting our plots. Thank you.